Welcome back to the Reptiles and Research podcast. Now, this is a chunky one. There's a 3.5 hours of hybrid gold, if you're into that. Now, I know a lot of people aren't going to be into hybrids and have some reservations about it, and we're just talking through the logic of like domestication and what they think it means, and there's real logic behind it. All I'm going to say is, if you listen to this whole thing and still disagree, feel free to comment. We're probably going to do a live stream in the future where you can go back and forth with us talking about it with the current guest you're about to listen to. So be respectful. It's okay to disagree. It's chill. Today's guest is Brian Reeder. Now, Brian's done a lot of work with goldfish and poultry and the history of domestication of poultry. He's doing a lot of stuff with daylilies. He did hybrid colubrids back in the day. He's done a lot of work and he's published a lot of books on poultry and the process of the genes and what's in there. It's a really interesting episode. I personally love to talk this through with Brian. This episode will really make you think. Let's get into it. Well, thank you for joining us, Brian. We've got in touch after basically you've seen a few of the hybrid rabbit hole that we've gone down, and obviously you've been really interested in the fact that other people are going down the rabbit hole. But could you just explain to us and our viewers the background that you have and why it was of interest to you?
Well, I've worked with plants and animals my whole life, and along the way, I came to understand that hybridization was a major part of basically phenotype creation in domestic animals. So that's been a thing I've been kind of obsessed with my whole life, and it's colored all the research work I've done. The main body of research that I did professionally was with genetics in poultry and in chickens. And that began as basically I just had chickens all my life. I kept chickens from the time I was a very young child and bred them. I kept daylilies, which is what I do now. My breeding program now is with daylilies. Um, and I kept snakes from the time I was a teenager. I've just worked with a lot of different animals, with the four major categories being poultry, North American colubrids. I did pythons for a while, but mainly North American colubrids, um, goldfish, and then daylilies. And I've sort of done all of those since childhood. So my professional research with poultry started out, I was just going to keep poultry, and then I ended up setting up research projects where I was looking at phenotype genes in terms of color. Various things led me to doing immunogenetic research, which is research in genetic disease resistance. It became obvious to me after a while that a lot of the phenotype genes in poultry were coming from the non-red junglefowl species. There are 4 species of junglefowl. So that made me very interested in hybrids and hybridization. So along the way, I decided to set up a program to look at domestication and hybridization with a model organism. And because I knew that there were easily created hybrids in the colubrids, the North American colubrids, that was what I decided to use as my model organism. The domestic fowl, chickens, poultry, their hybridization would have begun 10,000 years ago, perhaps. And so it's a long way back. Domestication and breed stabilization in poultry started, millennia ago. And so we can't really look at the beginnings of that in the same way that we can with a species that's never been domesticated. And snakes are in the process of being domesticated right now, whether snake breeders want to acknowledge that or not. Just keeping them in those plastic boxes mean you are domesticating them. That's the process. That's the beginnings of the process. So I wanted to look at them as a model organism for hybridization, and then how domestication can arise out of hybridization in the form of breeds, which are not known in the wild. In other words, how do you get some of these crazy chicken breeds that look nothing like a red jungle fowl? How do you get some of these crazy dog breeds? And of course, some domestic animals derive from hybridization and some don't. You can get them both ways. You can get gene pools that are later generation stabilized mutations, or you can get gene pools that are later generation stabilized, stabilized populations of hybrid origin. Now, when we think about hybrids, we're often thinking about the F1 hybrid. But what I wanted to look at was to go further and look at what happens in F2, F3, F10, F400. What happens through this whole phase? So that was a body of work that I did that falls in line with a lot of what you've been talking about recently on your podcasts. And I follow milk snake mutations on Facebook. And so I saw that he was going to do the podcast. And so I watched it and I really enjoyed that conversation that you all had. And it fell in line with so much of the work that I've done. And so that's why I contacted you and why I wanted to reach out, even though now I work with daylilies, which again are a domestic hybrid population that are made out of multiple species and were made within the last 100 years. So we have a lot of access to early domestication and hybridization information. Basically, everything I've worked with has involved this process. And so I've involved myself with studying it from the time I was about 18 or 20.
What do you think has fascinated you about the process of domestication so much?
I'm also an artist, and it's art. It's pure art. Um, the fact that anyone would bother to select for something visually appealing, well, that's art. We can say, oh, it's management, it's husbandry, it's art. And humans, no matter what they're doing, have a tendency toward art. And so that is the art side of it. To me, I compare understanding domestication and hybridization and selection and mutation to like an artist knowing how to mix pigments. It's your tools. These are the tools that you, as an artist, use to create your art. And we work with living art. And so for me, I enjoyed as a child and as a teenager the process of working with the animals, care, feeding, just like I do with the plants now. Um, I enjoy the physical process of husbandry. But as an artist, the thing that keeps me going back to do that husbandry work is the art of it, the ability to manipulate and create and maybe create something unique or maybe perfect something or maybe just bring something to a higher level. That's the thing that I love so much about it. And then it's just interesting. I just love information and knowledge.
What I wanted to really ask was in
Yeah.
your study, at what point did you define what domestication was and like when they were
Mhm.
domesticated, if that makes sense?
Yeah, what I found is that at about the fifth or sixth generation, you can start to say that something is no longer just a hybrid. You know, you start to see stabilization, and this has to do with background genetics. When you start to stabilize the background genes, and you're making selections, that's about the point where you can say, okay, I no longer have a species. I no longer have the wild types. I no longer have just hybrids, which are kind of uncontrollable. I'm now starting to have a breed. And that's when you really start to move into domestication through hybridization. Um, the true marker of domestication, though, is a specific genetic change that occurs in all domestic animals. Now, I don't know if that's in the process of occurring with reptiles right now or not because I've not seen the gene typing on this issue. But in all the domestic animals, there are genetic changes, and they're almost the same across all of our domestic animals, whether they're dogs or chickens or turkeys or cattle or horses. And that is that there is a change to the function of the adrenal glands that allows the domestic animal to not have a flight response from humans. So we can say that in the domestics, there is a specific genetic marker that indicates domestication. And interestingly enough, humans have that same genetic marker. Of course, we've domesticated ourselves. That's why well, I mean, we're still a fairly violent species, but it's why we're not just, it's why it's not murder day in and day out. We've lost some of that. And so even though we were always a communal animal, now we have this that's kind of calmed us, it's taken us down a notch, just like it has all the domestic animals. So there's a true marker for domestication. But then what I also found in like looking at the daylilies over time, because since we're only 100 and 110, 120 years away from the very beginning of that, and we introduce daylily cultivars. An individual clone gets introduced and propagated, and then I'm still growing things that Dr. A.B. Stout introduced in the 1930s. So you can look at the progression of the daylilies and say, okay, they're still looking very much like species until we get to like this break off point, which is about 5, 6 generations in, when you start to see background genes combine in such a way with mutations that they no longer quite look like the species. I found the same thing with snakes, and then experimenting with the jungle fowl species, I also found something very, very similar, because I was doing a project where I would take red jungle fowl and hybridize them with the other jungle fowl. And then at the same time, I was doing this thing with the North American colubrids. And about 5 generations in, you're starting to say, okay, this doesn't look like anything else anymore. It doesn't look like the species, and it doesn't look like the hybrids. It's now starting to stabilize, and that's kind of the same with the daylilies too.
With this gene that affects adrenal function, that you see like
Mm-hmm.
similar across the board, well, we've got things like Rare
Mm-hmm.
Genetics as the company for like finding the primers and stuff for like phenotypic genes for like morphs and stuff and ball
Mm-hmm.
pythons. Technically, they would
Mm-hmm.
have mapped the whole thing out to get primers and stuff, right? So
Right.
they would, if you were to actually have a conversation and be like, "This is what I'm looking for." Technically, if it's there, they
Mm-hmm.
would be able to be like, "Here, have a look," sort of thing.
Exactly. If it's present, if it's even present in reptiles, remember their adrenals are going to work very differently than in higher animals like mammals and birds. For instance, there would be no way to go to daylilies and look for such a gene. There's no such gene known in plants because they don't have adrenals. Um, Snakes have very different adrenal function, so I don't know that that's going to work the same in snakes. I just know what the markers are dealing with the animals that I've looked at and that are commonly known and researched. But yes, if anyone wanted to go dig the papers up online, you would be able to find the specific mutations, and you could look for similar mutations in any of the snakes. It's just something I didn't do and didn't want to do or really know how to do. I don't do gene testing myself. I work with other researchers. I'm have always been an independent researcher, and I wasn't in the lab. I was sending samples into the lab that were then being tested. I was doing the hands-on end. I was the one out, cleaning pens and moving birds and feeding snakes and doing that kind of stuff. Yeah, but yeah, it should be there. If someone wanted to type it, I think it could be typed. Yeah,
That would be so interesting. So when you were
absolutely.
looking at
Now,
the,
mhm.
so go ahead.
Oh, I was just going to say, last episode I watched with you, where you discussed hybrids. I believe it was the episode you did right after the one with milk snake mutations. You mentioned that our selection in captivity for temperament, that's the doorway to it. You said it's changing them. They're not going to be the same as the wild populations, even if they're locality. If you've selected the calmest animals with the feeding response that you want, that feed on what you want them to feed on, you're changing them into a domestic version that's no longer that wild locality or wild species. And that's 100% correct. And that's the doorway to these kind of things, because what we suspect is that in the ancient past, the wolves, for instance, that became dogs were the wolves that lost this mutation in the wild on their own, or gained this shutdown mutation in the adrenals. And so they were the ones that would come around the human camps to scavenge. We think it was the same thing with the jungle fowl. But even if it was not in the wild populations, let's say, for instance, that our early ancestors up in the northern steppe up above the Black Sea, when they started domesticating cattle, let's say no cattle had this mutation, but it was carried in the population. If it was carried in the population, they could have found calmer animals that would have been just like the wolves, the ones that would have come in closer to them, or through selection and captivity. If you keep selecting the calmer animals that will interface and interact with humans more efficiently, you're selecting for that mutation. So it's a self-reinforcing process once you have the original domestic mutation, and then you start selecting the calmest animals that are the easiest to manage. What happens then is you start gathering modifiers and minor genes that reinforce it and make that stronger. And we see that in chickens. There's a whole range of levels of domestication in chickens because you've got like fighting chickens that are calm toward humans, but are extremely aggressive toward each other, male on male aggression. But then you've got the large Asiatic breeds like the Cochin, the Chittagongs. It's a group of breeds that came out of China, out of historic China, that then influenced breeds in the West, and they are extremely docile and don't even tend to have male on male aggression so that you can keep multiple males together. And that occurred because the Chinese set up poultry breeding programs in every state within China that was sponsored by the state. And this was done to have poultry to feed their vast armies. So they wanted egg production and they wanted meat production. So they're constantly selecting for calmer and calmer and calmer birds over centuries. And through doing that, they turn out with these big, giant, huge birds with basically just shut down adrenal function that are calm with humans, calm with each other, and just put on meat like crazy. All of our production meat breeds that are now the base of the industry all derive from that. So as we are selecting in captivity for calmer snakes, we're probably doing something like this, even if it's not already a thing in the wild population. But when you go out and you see a reticulate python that tries to eat your arm off in the wild, and then a reticulate python that just sits in your hand in the wild, and they both occur, leads me to think that the genes may already be there to begin with, or the equivalent that would occur in reptiles, whatever those are.
Well, it's like I don't know if you know of dragoon geckos, but it's a leopard gecko breeder. And one of the things that she selects for is male aggression in like copulation. So the really aggressive males, if they're really like aggressive in the way they bite and hold on, they're the ones that are removed from the line until she gets to the point where she has like really calm copulations. So that temperament there is something such a specific thing in terms of temperament of like in that scenario that she's controlled for. You could totally see how different things would be like towards this scenario or towards this scenario and have different temperaments depending on what scenario it is. And we already have proven that it's happening because people are doing it.
Exactly. And any selection like that is going to change because remember, um, we know from all animals and from humans that sexual drive is mediated in part by the adrenal glands. So whatever adrenal function would be involved in that, her selection for the geckos in that way is selecting toward a calmer variant. Um, I mean, I don't have to have looked at a gene typing chart to know that that's making changes. It's just what it does. And this is domestication. This is what domestication is. It is us making the choices that would never be made in the wild. It, you know, Darwin basically based his uh, evolutionary theory, selection of the fittest, on domestic animals. But domestic selection and wild selection, while it's the same process, are very different things. We're selecting for what we want to work with, while nature is selecting for whatever by random chance survives. So it's the same process, but with very, very different outcomes and very different. We are intentionally focusing on something. Nature doesn't intentionally focus on anything. Nature's just random chaos until something makes its way through to breed. you know.
Yeah, it's funny because we're such at the start of a huge process, and because we're right at
Yes.
the beginning, a lot of reptile keepers just cannot see it. It
Right.
reminds me of the analogy is like there's more time between Stegosaurus and T Rex, between T Rex and us. But when you say that, people can't
hmm
comprehend because it's two dinosaurs, right? But the
Yeah.
time difference is gargantuan, and that's the same of the
hmm
time difference it takes for actually to get onto miles down the road in domestication where you really see it. Because we're at this very start, people can't see
Yeah.
it, and it's the same as that dinosaur analogy, I think.
I agree. I mean, I can see it in the snakes very clearly. I've been aware of snakes and aware of morphs and aware of the hobby in general, the herpetological hobby, since the late 70s, early 80s. And so I can see it. All of these morphs. I mean, to me, I'm just looking at breeds. I mean, and breeds aren't a real thing. Breeds are just artificial selection toward homozygous base that's homozygous and stabilized in its homozygosity for a
You've
certain
locked it
set of
in,
select
yeah.
genes. Yeah, exactly. Um, a lot of what's going on now are land races. I see a lot of stuff in the reptile world that I would look at and say, well, that's a land race. Because of the way everyone keeps breeding the different morphs together. And thank goodness, it's better to have a land race than to have breeds. In poultry, there's a lot of problems, just like in with dogs or with uh, fine horses, fine purebred horses, where people will inbreed a line into the ground. And you touched on that too in both of the hybrid episodes I recently saw, that it's better to maybe have a hybrid that's not 100% pure and have it strong and hardy and vigorous than to have something inbred and weak and, no longer viable, non-viable. But it's pure. Well, you see this in every group. And one of the things that I think is really good in the reptiles is that you all keep blending morphs, and that keeps gene pools a little more open. I think the worst thing going on in reptiles is locality, because that level of inbreeding is going to result in the single sire phenomena that we know from racehorses and show dogs and show poultry, where you basically, like Rhode Island Reds at one point got so bad, the show type Rhode Island Reds, which is an egg laying breed that was bred specifically for high egg production. They could produce 250, 300 eggs a year, but show lines were producing 25 eggs a year, and you were lucky if 10 of those eggs hatched. So
Wow.
that's something that I'm starting to see these things. I mean, because I don't have any reptiles anymore. I don't have any animals. You couldn't run fast enough to give me an animal. I've moved on. I like things that are planted and that never move or say anything. You know, that just has just happened to me with age. But I keep up with it because it's fascinating and I love it. I love seeing the morphs and I love seeing what's going on. And so I follow a lot of people and go to websites and go to the various auction sites and look at what's available. And I see things that I think are indicators of too much inbreeding on the purebred side. And then I see things that on the hybrid and morph side are working better because they're keeping the gene pools more open. And I think that's a really important thing to stress, is the importance of not trying to lock things in too tightly. But you certainly can when you hybridize and then start selecting. You can make these breeds. And I'm kind of seeing that start to happen. But it's a little different where you all keep blending morphs. Because maybe one morph occurred in this locality and one morph occurred in this locality. And so you're blending different gene pools as you're blending morphs. So that's a good thing that I see in the reptile world right now.
I think one of the things that reptiles struggles with as well is that a lot of the origins of a lot of these lines and breeds being produced in other like cultures, like fish and birds and stuff, was at a time
Hmm.
where there wasn't really a stigma around culling, but because it's like a modern
Yeah.
thing now and current of reptiles, there's this weird thing with culling
Hmm.
where everyone's funny about it, and it's like if you
Yeah.
talk about it, it's this awkward thing. Um,
Yeah.
but a lot of these things of these localities that they're doing, or these certain lines, they would be a lot healthier
Hmm.
now if they were like applying that selective pressure of like if you aren't good enough, you're getting cold. And because people have been
Hmm.
not weak, but like haven't made those hard decisions to keep the population as a whole healthy, a lot of those problems have come in now. Because a lot of people
Yeah.
don't understand what line breeding is. A lot of replicators have been saying, well, on the third generation, you can do it 3 times father to mother, and it has no effect. And then, but all these weird random rules that have just popped out of nowhere in reptiles, because it's all made up.
Yeah,
And at the
it's
same
that's all
time,
made up.
that
Yeah.
alongside the oh you can't cull because that's wrong, it's just a recipe for disaster.
It absolutely is. You've got to cull. Now, culling doesn't mean you have to kill it. Cull and kill are not the same word. It just means you have to take it out of the breeding pool. The easiest way to do that with reptiles is pass it into the pet world and don't breed it. But the problem there is maybe someone's going to buy it as a pet and they're going to end up breeding it. I advocate for culling means killing. I cull daylilies like crazy, but I'll tell you this, in the poultry world, in the daylily world, where I've done most of my work, you have factions that also don't want to cull. And in the poultry world, really? I mean, I, that always blows my mind. It's like you can eat your culls.
Mm.
And I realize people are squeamish, and I realize that it's, all this stuff. And maybe people are keeping them just as pets. But I always say, well, that's great. If you're keeping it for pets, just please don't breed from them. You know, if that's all you want and you want to keep this animal that has a problem, I'm humane. I believe in that. I don't think it should be put down if you love it and you want to keep it. I think that's great. Just please don't breed from these bad animals. You don't want to pass those genes forward. You're not helping anything. And then the same with daylilies. We see problems in daylilies. We see a lot of inbreeding now. And something that you mentioned a minute ago was about the reptile people don't see the domestication. Well, daylily people are over 100 years into producing these fancy garden hybrids, and they still don't see that they're domesticating. So, I write articles all the time about daylily domestication, and and daylily people often just it's like, but we're just breeding garden flowers. That is domestication. You know, one of my projects actually is that the tetraploids with its doubled chromosomes. So instead of diploid two chromosomes, tetraploids have four. So they're bigger, more robust plants, but ours were made through conversion rather than through natural breeding. There are species diploids and species triploids, so theoretically you can make tetraploids from the triploids by breeding triploids together. No one did it. They made the tetraploids through gene conversion using colchicine. And so that created a lot of chromosomal misalignments and problems that no one ever ironed out because they immediately, as soon as they got them, went crazy breeding flowers and focused on nothing else. And so the plants have problems. My central program is in going back to those triploid species and crossing the fancy hybrid tetraploids to those and creating a tetraploid polyploid gene pool that has a more open gene pool, higher fertility, and that has a lot of these chromosomal misalignments ironed out. And so I'm about 15 years now into that program, and it's working really, really well. And as I describe my program to other daylily breeders, they don't quite know what to think about it. They're like, they often get offended because they think I'm like putting down their fine tetraploids. And I think the work they've done making beautiful flowers is wonderful, but they forgot there's a plant under it. And I'm telling you this. I know your reptile people aren't going to be that interested in hearing about plant breeding, but it's exactly the same thing. Breeding is breeding. It doesn't matter if you're working with plants or animals. That's the reason I've been able to move back and forth between different things, is because I don't consider myself a this, that, or the other breeder. I'm just a breeder. I'm obsessed with genetics and breeding and strain formation and the process of domestication, whether that derived from mutation or hybridization. So if you take a broader view and step back from the details of the thing you're breeding, you'll start to see that it's just an umbrella and it's all the same thing everywhere. All these processes are exactly the same. And so you can go and look at something like chicken people or the chicken world or domestic poultry that has thousands of years of domestication behind it. And you've got all these amazing breeds that derive from this hybridization, all these different phenotypes. But you're now at a point where you've also got a lot of problems that derive from about the last 150 years or so, where people have been pure breeding. And that's a thing that I would say to all reptile people listening to this, is to strongly caution them to cull and to keep gene lines open. The worst thing you can do thinking you're preserving something is actually kill it through inbreeding it until it's non-viable. And things will become non-viable fairly fast. But here's the key to what you have to do. You have to test mate. In plants, that is, I put the pollen of that plant on its own stigma and I self it. You can't get a tighter inbreeding than that. That's basically cloning. And the reason I self is I want to know the level of deleterious hidden recessives that are there, because those are the genes that cause quote unquote inbreeding depression. So I self, and then I will breed those very closely to close relatives, like a sibling to one or both of the parents. And I do these test matings to see how much deleterious recessives I'm dealing with. How many of those are there? Are there a lot of them? Do things just go horrible in the first generation from doing that? Or do things get better? Because here's the thing with inbreeding. If you've got a lot of deleterious recessives, you will ruin your line through inbreeding. But if you don't have a lot and you've got some good traits there, inbreeding then becomes a tool where you can intensify good traits. So it depends on what you're actually working with, and the only way to know is to test mate. So in snakes, take a offspring back to a parent as a test mating. You know, a test mating means you may call all the offspring. They may come out horrible. They all may come out weak. One thing you see a lot, those little twisted ends on tails on snakes a lot. Where the last vertebrae is twisted and it kind of, is like weird looking on the end of the tail. It's like a little knot or something. That's a deleterious recessive. That is an indicator of inbreeding depression. If a line is starting to throw those little twisted tail ends, you're having a problem. If you start getting like crinkled scales, the little twisted lips that you see in some lines, little things like that, those are the kind of things you want to be looking for. They're not going to kill the snake. They're not going to keep it from reproducing, but they're just little things starting to creep in. So if you breed an offspring back to the parent, or you breed two full siblings together, which I know is how most people breed anyhow, but that's not the best breeding you could ever do unless you've test made it and you have a really strong line that's not showing any deleterious recessives, and then you can inbreed that line. Another thing you want to look out for is an exceptional individual. Individuals that never get sick when everything else gets sick. Individuals that never show problems. Individuals that always feed well. These exceptional individuals that are spot on with every trait you want. Test mate that individual. If it doesn't have a lot of deleterious recessives or doesn't show any, that's one you need to inbreed. You want to inbreed for strengths. You want to outbreed for weaknesses. And that's how you develop strong lines. But that's the reason the locality stuff is going to be a problem. It's already becoming a problem, I think, in certain areas. It's going to be a bigger problem on down the line. And I agree with something you said in the recent podcast you did, that the future lies in hybrids and morphs. Because that's what it always lies in. And the thing of it is, you may have a morph that's an Okatee corn, or you may have a morph that's a Miami corn, or you may have a morph that's a banded cow king. But once it's been 100 generations in captivity, it's now just a morph. It's not
bang on.
Yeah, it's just a morph at that point. It may be because in chickens, here's a perfect example. We have a color variety called BB red, is what they call black-breasted red, that I would refer to as red duckwing, because it's the red pheomelanic allele combined with the duckwing E allele, or the MC1R receptor. It looks just like the red jungle fowl. The male and the female are colored just like the red jungle fowl. But chicken breeds with that color form are not red jungle fowl. They now have a morph. And that morph looks just like the red jungle fowl, but it's not. And that's the same with any of these locality morphs that you see in the snakes. You may choose to breed the ones that look just like they look in the wild, although obviously, just as you said in that last podcast, you'll pick the prettiest ones, but they're no longer that thing from the wild. They are now just a captive bred morph. And that's a real important thing that people, I hope, can come to understand in time.
Just a quick one. If you are liking this style of content and you like this back and forth dialogue and discussing ideas, then consider joining our Patreon. On Patreon, we're doing courses and lessons, as well as doing monthly calls where we talk about topics in detail like this in a really advanced way. We also have things like Journal Club, where we get together and I read a journal to you and we pick it apart and we build up the skill sets on how to read scientific journals. So if you're interested in going deep into subjects, the Patreon is the perfect place for you. I'm really proud of it, and if you're into this level of depth of conversation, you're going to love the Patreon. Head on over to Patreon/Reptiles and Research, and I'll see you over there. Back to the episode. We're on the train, and you can't get off whether you like it or not, because it doesn't matter.
No.
If you breed, you're on the train. You can't get off. You have to be having constant gene transfer between your collection and the wild coming in. Otherwise, it's not a locality. Basically,
That's
locality
correct.
doesn't exist.
I agree. Well, locality where I live, we have the Lampropeltis niger, the eastern black king snake, and I have a lot of them around here. I love them, and I see them all the time, and they never look alike. So what would a locality from my garden look like? Well, I don't know. There's 3 or 4 variations. And where they're just all breeding together and there's no selective pressure making one or the other become the only one. Which one? Which one's the locality? Which one's wrong? You know? I went to school in Florida and I used to herp all the time down there, and you'd catch a corn snake that looked just like an Okatee, 300-400 miles from Okatee, North Carolina. Then right beside it, maybe under the same piece of tin, you'd pull out one that looked just like a Miami. So what what do any of these morph names even mean? They're not real things. But yes, but I would also say that in like with the chickens, for instance, people are really hung up on breed, and you've got all these breeders that you can never cross breeds, or you'll ruin them and you'll have mutts and mongrels, and you can never cross breeds, just awful hybrids, you've ruined the good breeds. Breeds are not real. I always say, man, breeds are not real. You are talking about stabilized later generation populations of hybrid origin. That's all they are. So it's important that as we domesticate these things, we not get locked into this notion that, oh, I can't cross the Okatee phase with the Miami phase. Well, Okatee and Miami looking phenotypes are crossing in the wild all the time, you know?
And you could have
So
like an
yeah,
Okatee that you've collected that carries the phenotype for the Miami.
yes,
Whether you call it those
that's right.
locations or not, but the premise is the same. Yeah, like it doesn't.
Yeah,
Basically, you've got
yeah,
those, like in
exactly.
that video I made, where it's the buckets of characteristics that you like, and you breed lines, and you manage those lines to maintain and proliferate the characteristics that you like, and that's basically it in a
Yeah, that's it.
nutshell.
That's it. And that's all a breed is. A breed is now. I will be the first to defend breed in the sense that once a breed becomes highly selected, you have a lot of background genes, minor genes, and modifiers, and probably even epigenetic factors that all work together. And if you cross 2 breeds together, let's say you cross 2 breeds of chickens, you've got a whole bunch of Mendelian genes that work in a real simple, straightforward way. They're dominant or they're recessive or they're co-dominant. But you've also got all these minor genes that have to then be ironed out. And so people say, okay, well, I've crossed a cochin to an Old English game, and there's 3 leg feathering genes and 1 fluff gene to get back to my cochin phenotype. But there's probably 15 modifiers, and they're all either dominant or recessive. And so if you say, well, I've got to select 4 genes and I wanted to get one bird homozygous for those 4 genes in the F2, well, you need one bird out of 256. So to get breeding capacity, you'd need to raise probably 4 or 5,000 birds. Then you'd have 20 or 30 you could pick over. But it's not going to work like that in practice, because once you breed up your 256, the one that is homozygous for all 4 of those genes may not then be homozygous for all the minor genes that are required to intensify that to the point you're used to seeing in cochins. So there's background genetics to consider. Breeds are not real things, but once breeds get really locked in or are kept separate for a long time, which is possible to do if you've got a lot of breeders. Okay, if you make your breed out of a huge genetically diverse group and you keep genetic diversity and you've got a lot of breeders breeding them, then you can keep a breed going for a long, long time, because then you can trade stock between breeders and each line will be a little different and there will be enough genetic diversity that you can do that. But where you've got very small populations, you often can't stay in breed and you have to outcross out of breed to bring in, because let's say you've got Rhode Island Reds again. Let's say you've got uh two show lines of Rhode Island Reds and they've gotten really bad and you know you've got to outcross them, and you get a bird from this line and you bring it in and you cross it in and you see a little bit of improvement but not much, and in two generations they're just as bad again and you're like, well, why? I brought in fresh blood. But if everything is equally bad, that doesn't give you hybrid vigor. That's not a true outcross. You didn't open the gene lines. That's what I'm doing in daylilies, where I went back to species stock and near species, to open up the gene pools of the tetraploids. Well, now what I'm seeing in the tetraploids are something vastly different. And I'm also starting to see traits emerge that we didn't really see in the tetraploid gene pool, because I've gone back to this other set of genes to open up that gene pool. And then what I'll do is I'll be able to inbreed for a long time because I've produced multiple lines and I can take my lines back and forth over each other. So I had four base plants. One was a species clone, one was F1 from a species clone, and two are probably F3 or F4 from species clones, but are still very close and are very, very non-representative of the regular tetraploid gene pool. And so by creating these four lines, by crossing those, and I didn't cross those with each other, I crossed those with the best I could find of the fancy tetraploids to create four families. And once I had selected the best F1 and F2 out of those families, now I'm starting to gradually weave those families together, always keeping them a little more one family or the other, so that 20, 30 years down the line, if this line is starting to get too inbred, I can go over to this line.
You can
And
freshen it
so
up a
it
bit.
freshen it up a bit, exactly, by having enough openness that I avoid things like the single sire phenomenon. Now, I've got one plant that's the most exceptional plant ever, and granted, in 2023, it was the only pollen I used on everything, but that is a test that I ran. That's a breeding value test. And what I will do is select a few of those. Some lines I won't select any from, and I will know what those come from, and I will always consider them, even where they have the other lines in them, they will always be predominantly this one exceptional plants line. So that the blood from the other lines it's not going to get intensified. It's there, but it won't get, in other words, I won't taint all the lines directly with this one exceptional plant. Even though that would be good in some ways, I'll use it, but I will always keep some stuff that doesn't have it so prominent, just because I have a lot of really good plants, even though this one is just hands down above all the rest of them. So it's a matter of creating a bunch of lines that can be braided, you know? Line breeding, especially the way it's done in like chickens or snakes, where you buy a pair of full siblings and then start breeding from them, is just, that's a uh, that's not even a gene tree. That's basically just a trunk. You don't even have branches, um, and that leads to disaster. That's the thing you have to be so careful of. If you're serious about breeding, you've got to bring in some different lines at the base to start building up from.
What are you thinking, Alex? I can see you like your brain's whirring. We haven't said anything yet. I know you want to say something.
No, I think that um I wish the general public would understand how complex breeding is when it's done right. Like when you sit there
Yeah.
and like listen to all the work that you have to put in at first, like all the mapping that you've done, you don't just buy two random
Hmm.
animals and put them together and change
Right.
the world. Like it's so much work. And people call themselves breeders if they're doing all of this work and it's the same as someone who is, and it's not. And this is you're either doing
Hmm.
that work for animals that you're producing for like producing hybrids or domestic species, or that's the kind of work that happens in conservation, but no one's doing that in captivity, but they think they are.
Hmm.
And yeah, it's just amazing
Right.
to listen to all the work that you're kind of like putting in.
Yeah, well, thank you. And it's just what it takes. And I want to be able, the reason I do it for myself is because I can't nod. I know what I'm doing. I can't look at like these plants, or when I was doing the chickens, I just couldn't look at what I was clearly seeing was I was no longer seeing a phenotype. I was seeing hospice patients. I was seeing this collection of deleterious genes being passed off as a fine breed that had all this value. When what I was seeing was something deformed, something afflicted.
Well, that's like scaleless
And
snakes in the reptile hobby, I'd say.
hate that. Yes. Yeah, or eyeless ones. Yeah. Yeah. Um, and there are a lot and I see it too when I see like one of the things that I would see in lines was like poor feeding response, where people would like force feed the neonates to get them to start it, and then you would have all these feeding problems. That's not just, oh well, that's the way it is. That's a deleterious problem, and especially when you can breed against that. But now I will end up rattling on without any organization forever if I don't say there are a couple things that I really want to touch on because I think they're important issues for your listeners to think about, and they're things that will be of interest to you, I think. One thing I want to talk about is just touch on the uniqueness of the North American colubrids, the big three, for just a moment. Another thing I want to touch on specifically is background genes and how important that is to the hybridization process, and why background genes play such a major influence in the way early generation hybrids look and breed. And then I want to touch on later generation stable populations as themes for us to talk about, because those are kind of, when I watched the two recent episodes that you've done on hybrids, you hit every nail on the head. And those were the two things that I thought, okay, this is the information I can add that will really tweak his understanding and bring it up to fill in some of those blanks. Like when you were talking to milk snake mutations, you were talking about like setting certain black and white lines of hybrids and how you could do that and turn those into breeds. And as I was listening, I kept thinking, okay, the two pieces of information that are missing are the background genetics and later generation stabilization. So those are just, I just wanted to throw those out there because we can talk about anything and we can talk as long as you want, but I want to make sure we hit those points.
Yeah, go for it. Go. I wanna. I
Okay.
wanted to let you run. I'm like what we don't know, and I'm like, oh, okay, okay. Tell me.
Yeah. Well, the North American colubrids, the big three, um, and my science language may be old. I think it's still Pituophis, Lampropeltis, and Pantherophis. Is that right?
Yeah.
Okay, okay. I know it used to be Elaphe. It took me years to get off Elaphe and go over to Pantherophis, but Pantherophis really makes more sense. Um, the North American colubrids are one of the most fascinating studies in evolution I have ever seen. For instance, the jungle fowl are far more genetically separate. Now, they emerged. What's really interesting to me is that the North American colubrids, the Hemeracalis, the daylilies that I work with, and the domestic fowls ancestors, the four jungle fowl species, all begin to emerge about 30 million years ago. And yet they've all gone in very, very different directions. So the four jungle fowl species are much more genetically separate, even though in their wild ranges they have overlap regions. So, like the green and the red overlap in certain parts of Indonesia, and certainly did in the geological past when that was Sunda land and most of it was still above water and not the Sunda Straits as it is now. Although they exploit different niches. In India, the red and the gray overlap, and in Ceylon, the red and the Ceylon jungle fowl, which is now Sri Lanka, um, overlap. But you don't have a lot of hybridization with those in the wild. And even when you do create hybrids amongst the jungle fowls, you get very low fertility. Generally, the way that's done is you breed the jungle fowl species onto a red jungle fowl or onto a domestic chicken, and then usually you'll get a few males that may have some fertility. Females generally have less fertility, and generally you'll take an F1 male and take him back into the red jungle fowl side. And so the main base of chickens is red jungle fowl. The mitochondria is all red jungle fowl, and you have additive nuclear DNA from the other three that came through males. Occasionally you'll get a fertile female, it happens, but it's not as common. With the daylilies, there's good fertility amongst any of the species. They'll go back and forth. That's generally not a problem. The colubrids, though, for animals, the big three in North America are shocking to me how much they will integrate, um, and how fertile they are. When you get 100% fertility in an F1 hybrid, it forces me to question if we don't need to rethink Linnaeus. I personally do not feel that they are separate genus. I think at best you have a genus that they all three fall in, and they are maybe subgenus. Or maybe there's actually only four species, and everything we call the species, like all the Lamprepeltis species, are actually subspecies or regional variants. Or maybe the milk snake and the king snake are actually two species. Truly, well, we still call them that now, but you know what I'm saying. Um, so that Pituophis, Pantherophis, and then the two kinds of Lamprepeltis. Maybe in the Pantherophis, the corn snakes and the rat snakes are actually separate species. But those are all so close and they all interbreed so freely, and they even interbreed in the wild. In their overlap ranges, they'll interbreed. But one of the things that I think has allowed the jungle fowl to remain separate in the way they have is that they never suffered from the ice ages. The same with the daylilies. The ice ages didn't force them into refugia like it did in North America. Um, I remember when I found the first paper on the Ice Age refugia, dealing with the Brooks phase of the Florida king snake, and that would have been like 2002 or 2003. And I believe the researcher was Paul Hollander. I can't swear to that, but I think so. It just a light bulb went on in my head, and I said, this is a whole different ball of wax, because what happens in North America is as the glaciers come down the continent, the snakes are all basically all the animals are driven into southern refugia, and it's not that they migrate, they die out. The ones up in the cold regions gradually die out. Maybe a few make it down, but for the most part, all you have left are the ones down in Florida and maybe the Gulf Coast and down into Mexico and Texas and parts of Southern California. And those are the Ice Age refugia. Um, and so when these snakes are being driven, we know that one of the keys to hybridization in the wild is disrupted habitats. So when the ice ages disrupt the habitats and the snakes are all driven down into the refugia, my guess is that whatever runs into each other and is horny breeds. That is nature's escape valve for extinction. So we know that the North American colubrids start to separate from the other branches of that family. So the big three separate about 30 million years ago. Well, that means they had a long time to be separate and to speciate. And then about 6.6 million years ago, the ice ages start. 7 million years ago. So that means that 7 times they've been driven into refugia. And that means that 7 times in interglacials, all snakes in North America repopulate from this southern refugia. So that means the black rat snakes and the king snakes in Wisconsin or Canada right now, their ancestors 12,000 years ago crawled up from Florida and the Carolinas and Georgia. You know, that's like, for instance, I remember when you talked to Milk Snake Mutations, you all talked about the renaming of the Pantherophis clades and how the relations run north to south rather than east to west. Where in the old days, when they were still Elaphe, it was thought that the speciation and the subspecies ran east to west, because yellow rat snakes run in a band east to west, and green or east to west, and black or east to west. But that's not how it works. They run north to south, so that the yellow rat snakes south of the black rat snakes on the eastern side of the Appalachians, where I live, are the same. They're more closely, they are the same. They're regional variants. Their color happens to work in their environment. And that's the reason over the course. And you have to think this has all happened in 12,000 years. You know, when these animals came up out of the South and moved back into these northern environments 12,000 years ago, right at the end of the Younger Dryas. So it's not actually fully 12,000 years ago. It's more like about 10, 11,000, 12,000, or 11, 10 to 11,000 years ago at most. Younger Dryas ends about 9,600 BC. So that's about 11,600 years ago. At the end of the Younger Dryas, um, the I, we can't say that there were black rat snakes that had traveled from New England all the way down into Florida to survive in that refugia. They didn't book tickets. No one announced that the Younger Dryas was coming. Um, so it begs the question: were there even any black rat snakes left during the refugia to repopulate, or did gray rat snakes go north and gradually the very plastic genome that they contain changed to match the environment of northern forests, and they became black rat snakes because that's what matches that environment? If that's the case, and that's what I believe is the case, there are no such thing as gray rat snakes or green rat snakes or yellow rat snakes or black rat snakes. There's this one type of rat snake, and it can take on different colorations depending on the environment it finds itself in, because selection pressures in those environments bring out the genes, the ones that because in any variable population, like for instance, we would go out and catch yellow rat snakes when I lived in Florida. They never all looked the same. You never saw them where they were all just beautiful yellow with perfect stripes. You had blotched ones and you had some that were darker. So and even like in the black rat snakes here where I live are beautiful. It's a brindled phase where the skin under the scales is bright orange and yellow and red. And then they've got the blotches on them. And the blotches are kind of separated in such a way that all that color shows in under them. And they're gorgeous, but they're very, very variable. And occasionally you see one that's almost solid black, so they go all over the map. Occasionally you see some that are more like a gray rat snake. Occasionally you see some where the yellow is really starting to come up more. So what would happen is in an environment, whatever's going to suit the best in this very plastic genome is the ones that are going to end up becoming the overriding population. So I'm of the opinion that what we're looking at with all of these snakes is an interbreeding clade of 3 interrelated or 4 interrelated super species that are able to breed and blend, and they have a certain set of genes. Because if we think about it, look at the genes they all have. They all have blotch phases, they all have striped phases, they all have banded phases. Now, we don't see the bands as commonly in the corns and in the rat snakes, but they do occur, and we certainly have mutations toward it. So we know these are the 3 major patterns. There's only like 3 genes involved in all of them for color. There's only like 3 basic pigments. So as they blend in and out, yes, they're always going to go toward the ones that are closest to them when that's available. But when that's not available, they can cross in the wild. And because we're dealing with just like a crayon box of phenotypes, whatever's going to work best in the environment they end up in is what ends up becoming the locality look. And so this is a plastic genome of things that, I mean, I think the big 3 North American colubrids are basically a taxonomist nightmare. you know, trying to taxonomy those, I think is a fool's errand.
Well, that's why they've tried to bring in like the tribes now in taxonomy, isn't it? They're all part of
Yeah,
Peltini, where does tribe sit? I
right.
think it's like subfamily, tribe, and then you go down. Yeah,
Hmm.
they're bringing in new things because it's just getting harder, isn't it? It's just this one big homogenous
Right.
soup, really, isn't it?
Right. Right. Well, Linnaeus did a good job with a really bad subject, a difficult subject. Linnaeus did a great job for the time he was doing it, the 1600s. Brilliant. We're 400 years later. We need to rethink this. It does not reflect reality anymore. And I think there at least has to be something. The North American colubrids, the big 3, convince me there has to be something between genus and species for some things. Now, like with the jungle fowl, yeah, genus, gallus, those 4 species, they're species. You have a hard time getting fertile offspring, but it can happen, and so they're part of a genus. But when you can get 100% fertility, uh, that's
It's very
just a
close, isn't it? It's very
question.
close.
Yeah, that's too close for comfort. That means they're all the same damn thing. That's what that means.
You've been saying
To
this for
put it
years, haven't you, Ellie, about the species concept?
Yeah, like I got taught by a very, very smart ecologist, and he blew me
Yeah,
in my mind in a lecture where I was like, "What is a species?" And he was like, "It's actually just
yeah,
bullshit because like species."
100%.
He was a specialist at newts, and there's many, many newt species that have been separated for a long time that will come back because, like you literally just described
Hmm.
with the colubrids, when nature throws a curveball in, they can jumble all those genes and then go back out, and they've just spread all of those. The more they keep the door open, the more chance they have if a calamity happens, they'll go back into those areas again. So yeah, it's just really interesting.
Yeah, I agree. And yeah, the concept of species is kind of bullshit. I mean, there's something there. There's something there, especially when you look at things that have been really wildly, widely separated. But for the most part, it doesn't. They're not static. They are. How would I say? They're porous. They're very, very porous. But I have a whole theory about why we were so set on that, 100, 150, 200 years ago, um, that are cultural and possibly even religious based that I won't go into. I won't bore you with that rant. But yeah, they are they're arbitrary. They work up to a point. But and like 10 years ago even, everyone thought all fertiles were sterile. Now, not in snakes, obviously, we were doing them. But if you just talk to the average layman on the street, all they're mules. But even all mules are not sterile. You know? There were allegedly true breeding lines of mules in Spain in the 14, 15, 1600s. So even the prototype animal that we get the term from, mule, we're not all sterile. So no, it's very porous, and it's more of a guideline rather than a fact. It's the way I would put that. Yeah.
There's going to be like colubrid nuts that like are pulling their hair out at that segment. They're going to
Well, I
hate it
feel
or
for
love it.
them.
One of the,
Yeah, I mean, I feel for people that this upsets because, indoctrination, the cult mind is a hard thing to get out of. I mean, maybe we need deprogramming for the species cult, because it's not real, it's not true. I compare both breed and species to religious beliefs, something we made up that isn't real, that we think is an absolute fact and will kill people over, you know? I mean, not to offend anyone. I don't want to be offensive, but I'm not saying anything about religion itself or about deities or whatever, but the religious beliefs are things we made up. That's what I'm saying. Just like the concept of species and the concept of breed. People in these breed groups, whether it's dogs or horses or chickens, will fight you over breed in the same way that these people will in the snake world over species. They'll get mad, they'll malign you all over the internet, they will backbite and backstab and if get up in your face. Um, so it's a cult mind. And clearly, if nothing else, the North American colubrids more than anything blows the notion of species out of the water. Because the fact that you can get 100% fertility just cannot track and keep those in the Linnaean structure that we've created for them. At the very least, there has to be something in between genus and species where you've got something that I would call maybe super species. And you would have maybe 4 or 5 super species of North American colubrids, subgenus or super species. I don't care what it is. I'm not attached to the words. But I think all of the Pituophis are one thing. I think there are 2 things in Lamprepeltis, and I think there are 2 things in Pantherophis. And then everything below that, regional variants, breeds, naturally selected breeds, I don't know what. Subspecies, but is even pushing it, in my opinion.
but then as soon as it comes into the pet trade, we're doing what we want with it anyway.
Absolutely. Once it's in the pet trade, it's irrelevant. Now, the one thing I did also want to point out with those the big 3 North American colubrids that I find extremely interesting, the greatest speciation the distance in speciation is between the Lamprepeltis clade and the Pituophis clade. because that is the one, if you're going to see problems when they're hybridized, that's where it occurs. Pantherophis falls between the two. It will easily hybridize with Pituophis, and it will easily hybridize with Lamprepeltis, 100% fertility both ways. But I have seen instances of going Lamprepeltis to Pituophis where you don't see 100% fertility, where you don't see 100% viability, and where you see some deformities like the little tail deformities and things. So that's chromosomal misalignments. So those are the two most distant ends. They're the two greatest points on the spectrum, and the Pantherophis falls somewhere in between the two. I don't think they're necessarily like a hybrid of the two, or of
I get what you
hybrid
mean.
origin, but they're closer related to both still. Yeah, they're sort of a bridge between the
missing
two things
link.
that have separated more. Yeah, exactly.
I get what you mean. Yeah.
So that was basically everything I wanted to say on the big three. I'm interested and fascinated by all the reptile hybrids. I'm really fascinated by all the hybrids they're making with pythons and boas, but I don't know as much about them. I've never studied them at the same level. I kept pythons and bred them when I was a teenager, and I just decided something that could kill me wasn't something I wanted anymore. I had a retic try to kill me. That was enough. 16-footer, she had mouth rot. I had her over my shoulder and was cleaning her mouth, and she was real weak, and I thought, oh, no problem. And she had coils around my head, coils around my neck, coils around my body. It took me and 3 other people to get her off of me.
Yeah, I don't.
So that
I'm
was
good.
the
I'll
end
keep
of
the corn snakes.
I like something. I would love to see people do some breeding with Pituophis and get some nice big giant colubrid hybrids that go up 8 feet. Maybe.
Well, the black rats do that, so that's
They do, but not commonly. You hear that all the time, but I have never in my life seen an 8-foot black rat, or any of the Obsoleta group. 6.5 feet's about the biggest I've ever seen, especially in captivity. Biggest snake I have ever personally seen in the wild locally was a black racer that was about 7.5 feet. That actually came out of my chicken house one day when I was feeding and startled me. Although I'm not scared of snakes, but it was just, here's this giant black lightning streak right between my legs, and I jumped up, came down with my foot in a bucket, and rolled down a hill.
I think what you've said in this is you've echoed a lot of things that me and Ellie have had personal conversations with. Like in between episodes, we're just like laying there at night, just like going over it and poring over it. And when you were saying about cults, it's so true because both of us have been like, it's such cult mentality about a lot lot of and I'd say I was deep in the cult when I first started. I was very deep, and I was like, I actually was like dead set against morphs because it has to be like all wild. And I think a lot of things that where it comes from is like everyone wants to bring that piece of nature into their house, right? So when it's not like, oh, it's not a pure corn snake and it's not like what I could go find outside. It's like it's boring if it's domestic and it's just a pet, right? And I think that is why there's like you can't covet something that you think is like not as sexy because it's not exotic.
Yeah, it's not as good, or it's not real in some way. Yeah, what I was originally going to do was conservation genetics. So you can imagine how uptight I was at one time. Yeah, that was going to be my original focus. And I just started to realize, oh, there's so many problems with this that it just led me in other directions. And people I met in the early days of going to college are the people who actually then got me started in doing the poultry genetic research. They knew I was interested in domestics. I had moved back home. I was raising birds, and someone contacted me and said, would you like to do some of this research? So, it's just like a path. I'm sure you've both gone down this path of one thing after another, this synchronicity, this little piece of information, this thing that you're introduced to, and it just starts to change the way you think. And suddenly you just find you're on a completely different trajectory than you started out.
Nothing really matters, basically, is what I've got to. It's funny because like a lot of the criticism that we got was like people will bring up like papers in the wild of like genetic drift or like hybrids reducing fitness in the population, and it's like, aha, see, hybrids are bad. I'm like, yeah, but that scenario is different. Like even if you produce like we cross like a gopher snake and like a king snake, and it's a loss of fitness, you just
Hmm.
cull and don't repeat the pairing again. Like everything that
Yeah.
goes forward should be because it works and you're getting good traits. And it's like things like I always use the MHC example of two papers that I really like. Do you know what MH? I assume you know what MHC is.
Yeah. Hmm.
Yeah, there's a paper on horses that the females would select MHC dissimilar males, but there was a paper in
Yeah.
this like trout where it was like they would actually select for like MHC similar like mates because it was like the theory is like the pathogens in that environment are like specialized, so the MHC
Hmm.
being similar means that they are keeping the fitness up, whereas if it would cross out, you'd get that loss of fitness. But all of that is
Hmm.
like wild examples. It doesn't apply because you are the selective pressure. Like, if you don't like it, cut it out, move on.
That's
Don't
right.
repeat the
That's right.
pairing. That's as
That's
simple as an explanation as a defense as you can get, really.
absolutely. Well, and to the notion that hybrids are somehow going to pollute the gene pools are already hybrid.
Yes.
This is the thing, especially with the big three North American colubrids. If they were all in that southern refugia, and this is why I wanted to really talk about the big three and the southern refugia. If they were all down there, how pure did they remain through that before they distributed back into the north? And how pure did they remain in that distribution journey north? Did they travel in packs? Because snakes are not pack animals, you know. So that's the thing is when and then they have overlap ranges. I'm in an overlap range, for instance, where the quote unquote black and the green overlap, and but that doesn't mean anything. It just means that we're in a biome that's beginning to be northern forest, and because I'm in the foothills of the Appalachian, I'm on the Cumberland Plateau. And so we're just at that region where we're not quite northern forest yet, but we're not really southern pine forest either. That's all that means. Um, Plus, in disturbed habitats, hybridization happens more frequently. So, as we cut down all the forests and destroy the natural world, we are forcing what remains pure to potentially hybridize. And then another thing to consider, most hybrids end up going back into one or the other founder populations anyhow, and they just flush back in, and those alternate genes basically get flushed out, and maybe one or two genes remain, and the only genes that are going to remain are the genes that actually help that species survive in its niche. So we are a fine example of that. We humans, we all carry a little bit of Neanderthal genetics, and we now know from testing that all living humans do. You know, once we said, oh, the humans in sub-Saharan Africa didn't, but now we know they have an even older Neanderthal extraction. So we're hybrid. And this is the thing. You will have a few rare instances where a gene pool has been fully isolated for millions and millions and millions of years, and they are literally their own thing. But almost everything else is probably somewhat hybrid, because that's just what nature does. It, in my opinion, is an escape valve to avoid extinction. If there's a male of this and a female of that, and they can get an even halfway fertile offspring, they're going to reproduce, you know, um, because the sex drive through the adrenals and through the other chemicals in the brains of animals and plants, not in the brains of plants, but you know what I mean. The sex drive is so strong in beings and living things that they're going to have sex no matter what. And if there's not one exactly like them available to have sex with, they're going to have some kind of sex. We know this. And that's going to result in boundaries being blurred. That's going to result in gene introgression. But it's also what keeps species viable over the long term. The most viable species over the long term are generalists. Well, generalists can live in the most environments and exploit the most environments. That also means they have the greatest possibility of encountering other niche groups and interbreeding with them. So generalists also are going to be the ones that hybridize the most often. That's the reason when you look at the genomes of the other hominids in our ancestry, they may not be as intergressed as we are. we have at least six other types of hominids integressed into us, where the others will only tend to have one or two. But that's because they each seem to have been more niche and maybe not been generalists in the broadest sense. Now, Homo erectus probably was, but Neanderthal and Denisovan, they seem to have been somewhat more niche than we are, or than our ancestor and their ancestor Erectus was. I don't know that to be true. It may turn out that they were just as generalists as we are, but there seems to have been more adaptations, and so they have less introgression. Um, so when you're looking at the things most likely to survive, they're also the things most likely to hybridize. So I question how much pure there is anywhere in anything. I think in time we're going to find, and our journey in the genomes of things is very young. We say we've mapped the whole genome, and we've mapped all that we can map of some things. But that doesn't mean we know everything about the genome. We don't know much about the epigenetic levels yet. We don't know much about all the modification factors. We don't know much about what the junk genes, because they're not, are doing. They're doing something or they wouldn't be there. Now, granted, you can carry genes that are shut off and that are no longer functioning, and we might call those junk genes, but you put the organism in the right environment where it's going to need those turned off genes, the epigenetic layer will turn those back on. So they're not junk, they're just laying in wait. You know, when you look at the evolution of life on the planet, here's the easiest way that I look at this whole subject. There is only one life form on the planet, and that is RNA. RNA is the life form. DNA is its library collection that it uses to take forms. And so there are four bases on this planet. You know, the four bases that make up DNA, and RNA is guiding how all of that forms proteins, and that's what creates all the vast array of form that we see. Now, we humans, being a visual species, we look at this and we say, oh, but this has two extra scales on its belly, and oh, but this has an extra petal on its flower, and but this jungle fowl has, three extra tail feathers or whatever it is. Oh, different species. Oh, it's clearly different. But, you know, I'm a lumper, clearly, in taxonomy. There are
I don't know why that tickled
lumpers.
me so much.
There are lumpers and there are splitters, and I am not a splitter. Splitters, everything with one extra scale is a new species. Um, I think it's the opposite. I think you have to keep moving back and back and back away to where we have far fewer species than we initially thought. Yeah.
I just thought of the perfect analogy. Do you ever see those
Hmm.
like YouTube shorts where it's like a paint mixing and a pour a color in and it would
Yeah.
change? It's almost like you've got like red and blue that you pour them in, it goes to purple, and then you keep pouring
Yeah.
red and it ends up back as red again. That's basically the perfect analogy for all of that.
Yeah, that's exactly what it is too. You're basically just especially with with a hybrid that then integresses back into one of the founder populations and one of the progenitor species. That's all that's happening, is you just flush out all those other genes. It's the reason, if you look at Homo sapiens, we carry probably as much as 40 or 50% of the Neanderthal genome, but each individual only carries maybe 2%. And that's because we've fleshed it out, and it's random as to which genes individual populations kept. Now, we know that there are certain genes that came from Neanderthal that almost all humans show, and those tend to have to do with well, not all humans, but most humans tend to show, especially out of Africa, humans tend to show, and that is genes that change hair texture and skin color and skin texture, and genes that change immunity. Those are the things that we tend to have kept in mass. But that's because Neanderthal had been in the glaciated northern hemisphere for, 6, 7, 800,000 years before its first integration into Homo sapiens again, which means that it had time to actually evolve adaptations to northern climates. That's why skin genes changed and became lighter for the vitamin D uptake, these kind of things. So of course we're going to keep genes like that. They give us a survival advantage. When we came up out of Africa, in the 70,000 years ago integration, that the big major migration that we all come out of. Um, we kept the genes that we got from them for immunity because there were going to be pathogens we were going to encounter that we did not encounter in Africa. So, of course, we're all going to basically carry those. But there's a whole range of other genes that are coming out of Neanderthal that we carry across the genome. But who carries which ones? That's random. And that's the same way it's going to be when we can do real fine-tuned genetic testing in like a population of corn snakes or rat snakes or this king snake or this milk snake or whatever. We're going to find that, oh, they've got genes from a whole bunch of these other ones, but it's just one little thing or it's this little thing. But then when you look at it in aggregate, they may have as much as 10 or 15 or 20% of the genetics of this or that other so-called species that they've integrated with at some point in the past. So it is very much that. It's very much like you say, like mixing those collars. If you keep putting something back in, you keep flushing the other thing out. And basically, you could have a pure corn snake, as pure as any corn snake on the planet, that 10 generations back had a obsoleta as an ancestor, or 10 generations back had a milk snake. I mean, look at the Eastern milk snake. You know, there are times that it's hard to tell the difference at a glance between an Eastern milk snake and a corn snake. You really have to know your snakes sometimes to tell the difference between them. Um, and to me, the thing that's most obvious is the difference in the neck. You know, I say the corn snake has a head of a horse, where the milk snake has the head of a worm. But it's
Yeah,
not as
yeah.
extreme it's not as extreme in the eastern milk snake as it is in the other milk and some of the other milk snakes and the king snakes. So to me, that's a clear area of intergradation. The eastern milk snake, I would bet money is going to be found to have corn snake genetics, or vice versa. You know, in fact, I wouldn't be surprised if the corn snake doesn't turn out to be obsoleta ex eastern milk or something of that nature. You know.
And then, yeah, even apart from what's happened in nature during all of that, during all of that, what's happened in the
Hmm.
hobby as well, like
Yeah.
it's like, oh, you've ruined hybrids upon hybrids that started as hybrids anyway, and it's like it's all hybrids. It's all
Exactly.
hybrids.
Exactly. Well, and that's the thing is, I think when we're talking about pure species or locality or any of these kind of things, we're fooling ourselves. Now, I'm not saying that they're all F1 hybrids. I'm not saying that they would even have much of an extraction, but I would say all of them have something 12,000 years ago that's not kosher with the purists. You know, at least 12,000 years ago. That period from about 11,600 to about 7,000 BC was a very warm period. It's one of the warmest periods that humans have known in the last hominids have known in the last 6 million years. And that is the period where the Great Northern Forest regrew from basically what was glacier devastation. There was nothing there when the glaciers were gone except rock and dirt. And that all regrew. And the snakes and all the animals came back into it. And they weren't, it's not like there were snake eggs that had been under the ice for 30,000 years that suddenly hatched and they were there. Those snakes literally had to travel inch by inch northward over hundreds and thousands of years to create full forest populations again. So I guess the main thing I'm saying is that I would pretty much bet a large sum of money that there were some wonky things going on in the refugia. You know, there were some things getting busy in the refugia that people would not approve of.
It's funny because it's like it's hybrid hominids keeping hybrid
Hmm.
snakes, feeding them like dubious hybrid rodents in artificial
Right,
environments, and then being like, "Yeah, but they're not pure, though, are they?" Like, what? It's just
right.
it's the whole
Well,
thing's hybrids.
yeah, it's like the old Taoist thing where the student comes to the master and says, "What does the world rest on?" And he says it rests on the back of a great turtle. And so the student goes away and thinks about it. And he comes back and he says to the Taoist master, "But if the world's resting on the back of a great turtle, what's the great turtle resting on?" And he says, "A great turtle." And so this goes on for several days, and finally the student comes back, and the teacher's tired of it, and he asks the same question, and the teacher just looks at him and says, "It's turtles. It's turtles all the way down." And that's what I see the whole thing as. It's hybrids. It's hybrids all the way down. As far back as you want to go, They've been hybridizing. It is a force of evolution. It is at its most frequent and most impactful in times of disrupted biomes. Well, disrupted biomes happen all the time. You know, aside from the great extinction events, there's constant disruptions and upheavals. So that means that it's hybrids all the way down. Yes, things separate and stay in groups for long periods of time, but that doesn't mean they started that way, and that doesn't mean they remain that way forever. There's constant gene flow between populations wherever that's possible, even if it's just marginal.
Our lecturers used to have like conversations about like using hybrids in like conservation and reintroductions, didn't they, Ellie? It's a very new
Yeah,
way of thinking, wasn't it?
because as long as an animal is in that place that is going to fit that niche, then nature will take and run with it, and it will eventually become what was lost. Because if that pressure is for that specific look and that specific animal, you'll get there eventually. And it's better to have that than nothing, which I was really for. I was like, okay.
Yeah, I agree strongly with that. I mean, because that's what's going to happen anyhow. If you have a degraded biome, whatever is left in that biome is going to interbreed where it can. So whether you are introducing a hybrid or whether you are not, it's still going to end up happening most likely. You know, if there are two viable animals there, male and female, that can produce a fertile offspring, they probably will. It's
I've
just
got this friend who had this conversation about it, and he obviously agrees, like, completely opposite direction. And we had this hypothetical he proposed to me. It was like, what if like MBKs were hybridized to something else, and then like you didn't have MBKs in the wild anymore, and you chucked them out. And I was like, well, if you just put those animals back out, and they were a little bit muddy because you've crossed them a few times, they would end up as jet black again because that's what
yeah,
the environment needed. And over like
that's right.
many generations, you're going to end up with it being basically the MBK again. It's just that it's originally not those original like little line from there to there. But it's like red and blue making purple and back to red again. Is it not red? So I was like, if it does
Yeah.
the job, looks and smells like an MBK, then I keep saying smell. Who's smelling snakes? But you get what I mean? And it's basically,
Yeah.
for all intents and purposes, an MBK. Like, why do I care? You know?
Well, here's what I would ask him. How does he know there were any MBK 12,000 years ago? Was he there? Did he collect some 12,000 years ago? Even if we have fossil evidence of a king snake at that time, unless it is petrified and we can sample the melanins in its skin, we can't know from its fossil remains what color it was. And any of the Getula, their skeletons are going to look identical. They're all the same species. So how do we know that there were any black ones 12,000 years ago? How do we know that the potential for those jet black ones wasn't just something that was carried in the genome of a very plastic group of king snakes that were in a refugia somewhere in Texas?
And
You
then
know?
suddenly it's really beneficial when it just goes whoosh and just spreads across.
When they can, then they spread into an environment where that is useful, and the genome being plastic, carrying a lot of phenotype genes. Because remember, dominant phenotype genes will hide recessive phenotype genes. But what's even more complicated is when you get all these minor genes and modifiers and codominants. You can have these effects where you've got codominance, and it can mask the full expression, so you don't realize that, oh, this black snake with a few yellow speckles is carrying is already a black, but it's heterozygous for jet black, and it's heterozygous for the speckled, and it's expressing both its codominance or dual dominance or whatever you want to call it. And so the phenotype you're seeing, that you're saying, well, that's a low speckling speckled. Yeah, but that's also a somewhat speckled black. It's both at the same time. And so you breed it to something carrying the same genes, you're going to get black, you're going to get speckled, you're going to get intermediates. You know? So we don't know that any of these phenotypes in the big three North Americans even existed as discrete units 12,000 years ago. You know? We know that they were carrying the genes. We know the phenotypes were present. They were probably much more what we would call land races, and that they were much more variable. You know, even the wild populations in those refugia were probably much more variable, and that variability allowed individuals of the same species to exploit slightly different biomes in the same refugia.
Oh, I find this topic so refreshing because you get to a point
Yeah,
where it's just like we're just producing the same things again, and it's like it's that and that and that,
yeah.
and it's just like anything new coming. Then I'm doing anything exciting. Then I'm doing
Hmm.
line breeding, treating it, or you're doing registries, treating it like dogs. Or, there's no new ideas coming. Well, at least I felt for a while there, it felt a bit stale to me, and I'm like, this is getting a bit boring now.
Yeah,
And then
I know
suddenly
what
it's
you
like, oh, there's
mean.
doors
Yeah.
opened.
Yeah, I know exactly what you mean. And I felt the same. And when I was working with the hybrids, back in the early 2000s, it was a dirty word. You know, you couldn't talk about it. You would be just resoundingly attacked viciously if you even so much as dared to breathe that, oh, a hybrid snake, burn you at the stake. And so it was hard to find him. It was hard to find information. I spent a lot of time just trying to get the information. I explained to people I'm doing research on the evolutionary nature of these North American colubrids, on the early phases of domestication. I need information on this, and people would just be vicious and horrible about it. And I always also would tell people then who were interested, you can make your own breeds. You can make anything you want. I kept telling people, why doesn't someone get some fox snakes and cross into corn snakes and see what different colors you're going to get out of that? What do these morphs make on the fox snake? I don't know if anyone's done it yet. I was going to try to do it, and I couldn't find the fox snakes that I needed, and that was all an issue. But there are all of these things that I look at and I think, you know, there, just like you said, things were stale, and everyone's sitting waiting for a new morph to appear. Why wait? Why wait? Make your own morphs, and of course those aren't morphs, but make your own unique combinations, and that's actually a great segue into the background genetics. Because when you make an F1 hybrid, if your two parents have been far enough apart for long enough that they have accrued a lot of minor mutations, they will have different background genetics, which means they'll have different modifiers for the same gene alleles. Okay, so the same loci will have different modifiers so that the same gene in this parent functions and looks different than in this parent. It's the exact same gene. What's making them look different are the background genes, the minor genes, the epigenetic factors that are turning things on and off. Okay, so when you cross those two and you've got, the two different chromosomes now recombined into this offspring, they don't resegregate at that point. You've just got this chromosome from this parent and this chromosome from this parent. So the reason you get such interesting, strange things in the F1 offspring is because you've got these things trying to match up that in a lot of places maybe don't match. Like maybe the gene for melanin deposition in this one is here on the chromosome, but on this one it's over here on the chromosome. And so they're, just a little bit separate. So they don't quite cross up. And so you get these really, because, in F1 hybrids, you'll see these things that look chimeric, that are non-reproducible. It's these chromosomal misalignments that create these phenotypes that are unreproducible. The chromosomal realignments and then the background genes not matching up. And so creating a unique look that when you then breed that F1 hybrid to another F1 hybrid, or you take it back into the founder population of one side or the other to get a three quarters, whatever, then those genes mix up. That's when you have meiosis. That's when they mix. That's when you can get chromosomal realignments. That's where you can get things to start to look different. But you're also never again past the F1 going to get that unique combination that you got in the F1 when these two chromosomes from two different species are lying next to each other. They're then going to start to blend. So it's just like your colors. It would be just like having a stripe of red and a stripe of blue. They're not purple yet. In the places where they overlap, you may get some weird little hints of purple. But then the next generation, you've taken a brush and you've gone through and you've done this up and down those two streaks. And now you've got all this purple blended through and it starts to look different. So now you're starting to blend colors. So that's what the background genetics are so important to understand. is that when you've got isolated gene pools, even if there was some hybridization 100, 1,000, 10,000 years ago, that's still enough time that you've still accrued, as long as they're a little inbred, as long as they've gone back to where all the representatives of that group look alike, there is enough inbreeding happening there that they're going to start accruing a certain specific functional set of background genes up and down all their chromosomes. So that's why those F1 hybrids can look really weird, and some of that stuff's not reproducible. But once you start making the later generations, that's when it starts reblending and you can start making your breeds and lines. This is exactly what we saw with the jungle fowl. It's exactly what I see with the daylilies. It's what the early daylily breeders saw, but not quite in the same way. Daylilies were simpler. They don't have as much going on color wise, or it's more hidden. It's more recessive, and it took more time to bring that back out. Um, Snakes, of course, don't really have any more pigment genes than daylilies do, but they have more unique combinations than the daylilies do. The jungle fowl only have melanin. You know, it's eumelanin or it's pheomelanin. They don't even have like the guanines and the erythrophores and things like that snakes do. But they still have very unique looks. So in the F1 jungle fowl hybrids, let's say you have the green jungle fowl, which has on the side of its face, its earlobe is a piece of skin on the face that is bright blue. And sometimes that blue will go up onto the top of the comb on the top of the head. But when you put that in the red jungle fowl background, it suddenly does something different, because in the green jungle fowl background, you have a gene that's called inhibitor of dermal melanin, which blocks the deposition of melanin in the skin. So the gene that's making the blue earlobe of the green jungle fowl is a gene we call fibromelanosis, which makes fiber the muscle fibers black, like skin and muscle black, or very dark, very melanized. So when you combine that into the green jungle fowl background that has the inhibitor of dermal melanin and the modifiers that go with that, on the earlobe, which is actually white, it carries a layer of white pigment that turns blue. But when you put it in the red jungle fowl background that has dark legs, it does not have the inhibitor of dermal melanin, makes the entire skin of the chicken, face, skin, legs, everything go jet black. And so you see these weird things that come out in the F1 that are real popular right now, called ayam samani. In Indonesian, that means black chicken, or a samani chicken, which is a thing that's jet black. It happens to have black feathers. You can have it with other colors of chicken feathers, but all the skin is black. Well, if you just knew the green jungle fowl and you just knew the red jungle fowl and you didn't know the gene and you didn't know that dermal inhibitor was in the green jungle fowl, you would think, how did this happen? How did I get a black chicken by breeding these two? And you would be very mystified by that. So that's an example of different backgrounds creating different looks. Like for instance, and I don't know this as well in the hybrid snakes. The genes, the basic genes of like banding, striping, blotching are not as well known. But my observation was that what you would see that is this same kind of thing are these very chimeric looking animals where it's like partially striped and partially banded and it's all broken up together and they're just weird looking. They're not one pattern or the other. That's the same kind of thing where you've got two different backgrounds interacting in such a way that they're not producing one or the other correctly. There's some kind of weird intermediate. And that's very difficult to reproduce in my experience. Especially as you get into later generations. Later generations tend to want to go back to blotching or striping or banding or something, because the genes are just going to go one way or the other. You would have to make a really conscious effort to select for the heterozygotes to get these kind of broken up patterns in the far later generations. But basically, it comes down to, if you want a certain phenotype, let's say you've got an F1 and you think this is really cool, I'd like to reproduce this, then you need to try to find something close-ish to it, you know, and work from there. You want to try to combine something from there and see if you can stabilize it. The problem with the hybrids is that not all of the stuff you see in those cool F1s is ever going to be reproducible. But by experimenting, you can figure out what is reproducible and then begin to set your own breeds. Like the example of the cool black and white stuff you were talking about, that will absolutely be reproducible in the sense that you can definitely select them to produce just jet black and snow white. And then you can select that into whatever patterns. You just need to know that you're going to end up going back into one of the three patterns, you know, or patternless. You know, you may have the mutation for patternless. I see that sometimes, which I think is really cool, where there's no pattern in just the black head, you know, like on some of the crosses with the milk snakes. Um, so those are things, but that's probably just a mutation as well that one or the other of the parent species is carrying that is able to express itself in the later generation hybrids.
Well, that's like if you take a Mexican black king snake to a corn snake, you think you're going to
Mm-hmm.
make like a darker corn snake, don't you? But actually, all what it
Mm-hmm.
does is it just takes all the red out of the corn snake, and you end up with like a
Right.
yellow and black snake.
Right. Right. Exactly. And you think about that, you know, think about that. Why should that be? Well, it's because that black king snake is actually just a yellow and black speckled or banded or blotched or chain king snake under the extra melanin. When you look at a solid black animal as compared to a blotched or striped or banded animal, you clearly have a mutation that is creating hypermelanization. Now, not hypomelanistic, as in the mutation that people work with, but hypermelanization, you know, which means that it's increasing the melanin deposition in the scales. So that's all that is. But that doesn't mean that it's not still, they're all just chain kings. You know, to come right down to it, they're all just chain kings. And then they have slight mutations that make them either super speckled or partially speckled or solid black or the crazy Florida Brooks looking ones that go to that super speckling or you know, whatever else you may have striping or banding. Those are just changes to the basic chain that you see on just the basic eastern chain king snake. You know, it's just like in the corn snake right now. You have domestic morphs that are striped. You have domestic morphs that are motley. You have the domestic morphs that are, I don't know, what else do you have? Do you have banded ones? Or there are bands in corn snakes, aren't there now?
Not in the sense of like as extreme as like a king snake, but you are starting to get like blotched, like banding down the backs.
Right, right, where the blotch is curving over and it's no longer just circular up on top, but it doesn't extend all the way down, but it's yeah, yeah, okay. Well, 10 or 20 more generations, that'll be banded. You know, if they keep up with that and inbreed it like crazy. You know, because if you're trying to see, that's not a single gene mutation, something like that. This is where it's an aggregate of minor genes. So you're talking about quantitative genetics, polygenic traits. So when you're looking at this aggregate of genes, the way you intensify that is by intensive inbreeding, because what you're trying to do is get more and more homozygous modifiers that's moving the thing a little further each time. That's when people get these breakthroughs where they get this one animal that's more extreme than everything else, and then it becomes the single sire, and everybody uses it in its offspring. And then everything from that point forward shows the better banding or the bigger crest on the Polish chicken or whatever it is. And that is an aggregate of minor genes. And that's the kind of stuff that with a trait like that you're talking about. And that's what the traits we're seeing in the difference between a cow king and a chain king. That's probably an aggregate of maybe a major gene, but a whole bunch of minor genes. Because I know when I've seen crosses of like chains and cows, they're kind of intermediate. And when you see kind of intermediate and then the F2 fall on a spectrum where they're all the way from chain to fully banded and everything in between, that indicates almost always polygenic and that you're dealing with a quantitative spectrum with a lot of minor genes. Yeah. But you know, when you see in any of these, like in the corn snakes, where you're seeing this now, and you're seeing all of these different morphs occurring that are the same patterns that you see in these other snakes. You see the striping in the obsoleta, you see the striping in the king, you see the striping in some of the pituophis. That's all the same thing, and I would be very surprised if it's not exactly the same gene. You know, the same major gene, and then there's just minor modification that intensifies things like that.
But that's like in the way that a corn snake and a king snake might like pair up. Like kings, very obviously, the male will bite the nape of the neck of the female, and
Hmm.
some corns do and some corns don't. And it's kind of
Hmm.
this like thing of being like, sometimes corns don't, sometimes they don't. But is that because we mixed in king snakes early on the hobby and our lineage has got a bit of king snake in it that does that, or is it because of the
Hmm.
interglacial stuff and it's all a big homogeneous soup anyway?
I would say the proto colubrids that they descend from, some did it and some didn't. And it's just, see, I mean, that's like, these are segregating behavioral traits. So no population seems to be 100% homozygous for it. The Lampropeltis seem to be the most homozygous for it, but I have seen king snakes that wouldn't lock on like that. Not many. Most of them, in my experience, lock on and try to eat what you're trying to breed them to. But I was dealing with a lot of wild caught animals too. But yeah, these are just behavioral traits. So these are things that are segregating in the population. I think those refugia would intensify it, but that's something that because they're all coming from a root ancestor. That's what's very clear. They all come from a root population of some kind of proto colubrid that they have all then evolved out of. And so all the traits we see in the whole superclade of the big three are going to be traits that were segregating in the original founder population and that have never fully been bred out or set one way or the other in most of the lines. And behavioral traits are harder to set. It takes real evolutionary pressure to set behavioral traits. Otherwise, behavioral traits will remain fairly individual unless there's a driving force in the environment that's causing that to be set.
It kind of links to like stabilizing the traits that you want in your hybrid lines later on, doesn't it?
Exactly. Well, and that's probably a good place to kind of start talking about that. Later generation hybrids and stabilization into breeds. Because that's something, that I know that happened in the chickens. I have pretty good information about, or at least very good ideas about how that happened a few thousand years ago. We don't have any information, really. We can infer from the genes how it happened. I have good information on that from the work I did with jungle fowl hybrids, on the work I've done with the daylilies, and what I've seen in the snakes. And of course, it's simple enough that a fool could do it. It's selection. I mean, here's the thing. Our ancestors did this with all of the early domestics with no genetic knowledge whatsoever. They did it simply by keeping in the breeding lot what they wanted. Now, they did not have breeds as refined in general as we have them now. And I don't know that that's necessarily to our credit or not, because we've used so much intensive inbreeding to have our breeds basically look like clones of each other, that's been detrimental to them. But um, our ancient ancestors could set these things. I mean, they made them distinct. A land race is distinct. It will have a whole group of segregating genes that are unique or distinct to a land race. And our ancestors did that with no knowledge of genetics whatsoever. They just did it by keeping. They were eating out of all of these populations, so they would eat what they didn't want, what they didn't want to keep. They would keep for breeding what they did like to some extent. Certainly in some cultures for religious ceremonies and stuff, the select animal was sacrificed, so that would have taken prime animals out of the breeding population. But it's highly likely such an animal would have already been bred from. Like I'm specifically thinking of things like bull sacrifice, like the Apis bulls of Egypt, or something of that nature. Um, Certainly there were other animals that were sacrificed, where select animals were sacrificed when they were young, like the sacrifice of lambs amongst the Israelites. Things of that nature would have taken them out of the population before they could breed. But something like an Apis bull probably would have already been bred from, because those were sacred bulls. Well, why were they sacred bulls? Well, they were sacred bulls because they fit a certain phenotype. Like you all have the what are they called, the park cattle from England, from there in Britain, the white park cattle. There's a famous herd of the white park cattle there at Chatsworth, and they are white cattle with black ears, black noses, and a black tail end, or it's red. white with red points. So they're just like a Siamese cat. And those have a whole layer of mysticism around them. Those were believed to be fairy cattle. And as you know, there in the UK, there was the fairy beliefs going back to the Celtic ancestors, even before the Saxons and the Angles. And of course, my ancestry is almost entirely um, Welsh and Scottish and English and Irish. So I'm obsessed with the Isles. I'm very obsessed with the history of the Isles, so I know it really well. And there was this obsession with the fairies. There was this belief in the fairies, and any animal that had that Siamese color pattern, white with either black or red points, were believed to be the fairy animals. And so you saw that coloring in hounds, you saw it in the cattle, you saw the fairy horses, and they also had the black or the red manes. And those were considered to be kind of sacred, and they were such a separate gene pool that those park cattle, the white park cattle, actually come down to us in the modern day and are one of the true brachio-Celtic branches of cattle, just like the Highland cattle. The closest thing they're related to are the Highland cattle, but they've been separate genetically from the Highland cattle for several thousand years. And they're very distantly related from anything else. And that is because of a color phenotype. So clearly our ancient ancestors were doing phenotype selection for coloring, because since most of the people who domesticated animals early on were animists, they would have seen these mutations or these hybrids as something sacred. They would have seen it as the spirits or the ancestors or the gods or whatever talking to them, or a sign, and they would have kept those animals and put emphasis on them in the breeding pens. you know so when it comes to like setting later generation populations, it's simply a matter of selection. But there's nuance that I can add to that. I mean, because I don't want to just in there and just say select what you want. The nuance would be that you need to kind of try to have some idea what you want, if that exists in any of the other species relatives to what you're working with. So, is there any python that has what your hybrid python is showing? Is there any North American colubrid amongst the big three that shows either in the morphs or in the wild forms that shows what you're seeing here? Have you ever seen anything like this? If you have, you're going to be able to set it, because that means it's just representative of the population, even if it's rare, even if it's just a domestic morph. Our domestic morphs are not happening because those animals are in captivity. The domestic morphs are happening because they're not getting eaten in the wild. We're keeping them. We're keeping something that's already happening. And a lot of those morphs come out of the wild. The original albino corn snake was found, I believe, just outside of Gainesville, Florida, in Alachua County. It was wild caught. Um, there are the original albino reticulate python was wild caught. Bob Clark had that animal for years, and he had trouble getting him to feed for 2 years, and then finally got him over the hump, and he would feed, and almost all of the albino retics descend from that one male. So a lot of these things are the original albino Burmese was alleged to be a wild caught. It certainly came out of Asia and was brought into the U.S. that they all descend from. So these are not, we call them captive morphs, but they're not. These are natural things that occur in those wild populations that just usually don't survive. Um, and Bob Clark, I'm going to go off on just a slight tangent for a moment, had a retic at one time that was the most beautiful snake I have ever seen, that was white and yellow and sky blue. And he's got a blue morph now that's beginning to get in that direction. But this one was white and yellow and blue. But he never got the animal to breed. I think one of the greatest tragedies in retics is that animal didn't reproduce. But anyhow, sorry for that little dirt road. But it just shows you that there are all these. But here's the thing that I would then say to him is the fact that animal exists, and you've got stuff now that's going in the bluish direction that they're calling a blue morph, means that through selection you'll be able to get to what that animal was at some point. The potential for it's there. It'll pop back up at some point. But the first step is to determine if this is occurring anywhere in a population. So in your hybrid population, you've got this unique look. Do you see anything like it anywhere? If it's something so unique and different that you've never seen it, then you're going to have to start to figure out how you think you can match that up. What are you going to try to match it with? Obviously, if it has a full sibling that looks vaguely like it, match it with that. If it has a full sibling of the opposite sex that does not look like it, match it with that, because you might get that to nick, as we call it in breeding. That's not a scientific term. That's a layman's term. If you can get it to nick, if you can get that to match up, the genes all match up right, that you can reproduce that, then you can produce that. But some things in your early generation hybrids are not going to be reproducible, and so you're not going to be able to carry those forward. The key is that each generation, as you make another generation and you go deeper into that and you're getting further away from the hybridization event, what is actually gelling? What actually works? What actually is becoming reproducible? Those are the things then that you can work from.
So when you say do like a sibling pairing to see if it nicks, that's basically your test pairing to see whether you've got it in there. So
That's right.
you're not necessarily saying like just go full like sibling that you like just to see that it's there, and then you take it out and you move a line out and you come back in and look after it like
exactly.
that.
Exactly.
See when
Go ahead. No, go ahead.
I was just because people were gonna. I know people would like have like half understandings would be like, "Oh my god, sibling pairing!" But it's just saying do the test, and if you don't like the clutch, you can cull the clutch and not do.
That's right.
But it's just
that's the test mating. Yeah, exactly. Well, and here's the thing: you're doing the test mating because that's going to give you the genetic relation that will tell you if the thing you're wanting to reproduce is genetically reproducible. The best chance you have of genetically reproducing it is with a full sibling, or back to the parent you think it might have come from. You want to inbreed and see if that's reproducible. If it is reproducible, then take that animal and outcross it to something unrelated, and then maybe backbreed to the male to set the trait, and then you'll know how that's going to work. Once you know how it works, then take it out to different lines. And then you've got several different lines carrying it. You can start blending them and bring it back out with a wide genome, on a more open gene pool. But no, I would never start a strain by sib-sib mating, but you've got to test that way, because you can't just go to any abstract old thing and breed it to and say, oh, well, it didn't work, I can't make that. You don't know. You've got to go to where the genes are right to know if the phenotype you're wanting to reproduce is reproducible at all or not. But that doesn't mean that's where you stay. Once you know it's reproducible, then you outcross it to unrelated lines and even to different things. And another little dirt road that I want to go on for just a minute is a subject that I think is really important to strain formation. And everyone wants to think about phenotype genes. Everyone wants to think about, I want it to look this way. I want it striped. I want it banded. I want it these colors. I want it blue. I want it, whatever. What people are not so quick to think about maybe is, what behavioral traits do you want? One of the things that I know from the chickens is that chickens are predominantly red jungle fowl. Why? Because chickens are where the original mutation for the adrenal change occurred in the red jungle fowl. That's where it occurred. And so they are the base domestic stock that the hybrids keep getting taken back over. They're the most amenable to captivity. They produce more eggs. They're more amenable to management. I always felt, based on that knowledge, that for me, if I had have gone ahead and developed lines out of the experimentation I did, that the corn snake would be my genetic base. The corn snake would be my hybrid Eve for North American colubrids, because I like all of them. But there are things about kings and milks I don't like, and there are things about Pituophis that I don't like. There are things about Obsoleta I don't like. There are things about Vulpina I don't like. I don't know if that's what it's called. That's a fox snake. I don't know what its current Latin name is, but it was Elafe vulpina back in my day. But there are things about all of them that I don't like. But the corn snake has it all. I love everything about the corn snake. The bigger neonates, the larger, the larger clutches, not bigger neonates, but the neonates are big enough. The eggs are slightly smaller than the Lampropeltis, but the neonates feed easier and they're very manageable, at least with most corn snakes, certainly with like the Okati-based lineages. So my mitochondrial Eve lineage for hybridization and in the work I did was based in and around corn snake. Everything that I did got brought in through corn snake. And that's the way I would do it, because I would want to produce the most manageable lines in captivity, so that you have all of these behavioral traits. You don't have ophiophagy. You don't have them trying to eat each other. All of these traits that make managing the Lamprey peltis or the Pitiophis a little more difficult in captivity. If I were going to do hybrids, I would keep bringing everything in through corn. They wouldn't look like corns necessarily. You could end up with things that look like milk snakes or that look like Lamprey peltis of any kind, but have the behavioral traits of your corn. That's the thing is, even if you're going to go with the corn as the base, doesn't mean you're going to end up with something that looks like corns. It just means you're going to end up with something that behaves like corns. Now, I'm not saying that's what everyone should do. I don't care what anyone does. I'm just giving that as an example of that's what I would do, and that would be an active domestication and breed development. That's domestication. That's higher level domestication because you're not just I made these hybrids and this one's pretty and I know I can reproduce it, and so I'm going to make these hybrids that look like this, but then they're difficult to breed, they eat each other, they don't feed well, the neonates have problems, blah 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 blah, but they're pretty. Please don't do that, guys out there, any of you guys, gals, anyone breeding, please 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 don't do that. Think about, if you're going to go to the trouble to make the hybrid and you're going to go to the trouble to then turn it into a domestic snake breed, what else should it have and where can you get that? Your first F1 cross doesn't have to include that. Be nice if it could. But when you've got your F1 and you're going to do your outcross, once you know you can do what you want to do with your F1 because you've done the sibling test mating or bred back to a parent, then think, what base do I want to put this on? Then you're breeding. Then you're thinking outside the box. Then you're thinking about the long term. You're taking the long view of, when I'm 20 generations into this program, what do I want these animals to be? Not just what do I want them to look like. What do I want them to be? How do I want to care for them? What do I want their management to be? So I'm doing that with my daylilies. I'm using zero inputs with my daylilies to make them as tough and vigorous as possible. Where I've got a lot of species genetics, I can do that so that even once I get back to really fancy flowers on these big giant plants that I'm creating, anyone can grow them. They are one of my advertising points is brown thumb immune.
That's brilliant. I love that.
Yeah. And so that's the thing. Idiot proof them. Make them to where the worst pet store out there can't kill them. That should be a goal for your hybrids. Make them to where the worst keeper out there cannot kill them.
Bomb proof.
That's the same thing I'm doing with my daylilies. That's the same thing I did with poultry breeding when I worked with immunogenetics. And that's another thing, disease resistance. There is genetic disease resistance. I've incorporated that into daylilies. That was the base of my research in poultry. You can do that in snakes too. Look for, when you have an outbreak of something, is there a snake that never gets sick? Is there a snake that's in with a sick snake or right beside it, so that there's been an exchange of body fluids in some way, or at least, they're breathing around each other. Um, so in other words, inoculation. A creature that does not show the disease when it has 100% been inoculated may have genetic disease resistance and immunity, and that is the best possible thing you can use. Because that's another thing, as we keep inbreeding, we keep losing immunogenetic traits. And if you're breeding from stock that didn't have it to begin with, you may even be increasing susceptibility. So these are all things to consider in the foundation of your line. Make them idiot proof, make them bulletproof, make them brown thumb proof, make them to where they survive. Because that's another problem we always see in domestication when we start pure breeding and trying to tightly inbreed, is that deleterious crop up and we get weaker and weaker animals that also then have more disease related problems, both behaviorally, physiologically, and also immunologically at the genetic level. And the genetic disease resistance is the most important disease resistance you can have. It's far more important than acquired disease resistance. So those are all things to consider when you're trying to formulate strains or breeds.
Basically making the super pet snake.
Absolutely. What's the point in doing anything else? I mean, it's just like you've said, the minute you put it in a box and you're bringing it its food and you're doing all the selection, you no longer have a wild animal. So people need to just kind of get themselves adapted to the fact that any intervention whatsoever changes the nature of the creature. And it doesn't matter what that intervention is, it will change the nature of the creature. And so you no longer have what you started with. You have something different. You have something that is domestic after just a few generations that can't be reintroduced into the wild, that just won't survive. Now, could you take them and readapt them to go back into the wild? Possibly. But the thing is, people who are keeping animals who want to keep them for conservation purposes should do that. But they need to know how to do that and be realistic about what that takes. And just like you've said, constant gene flow from the wild. Every second or third generation needs to go back out to freshly collected wild stock. That's not going to be possible for most things. But where it is possible, that's what you have to do. That's what zoos do. They can get their permits. They can go out and collect these CITES 1 and CITES 2 animals and bring in and cross in. Um, you can do it certainly with corn snakes and some things like that, but there's a lot of animals that's not going to be possible with for long. So if it's no longer possible to do what's necessary to keep them as wild, reintroducible animals, then what are you doing with them? At that point, you are domesticating them no matter what you call it. And if you're going to domesticate them, at least get smart about it. My biggest complaint with all animal realms and plant realms is the tendency to maintain weak stock. That's my top complaint, to keep and reproduce and thus intensify weaknesses. Nature wouldn't do it. And we somehow think when we do it that is making this more valuable animal. I have often said that there seems to be this tendency among breeders to think the weakest creature is the most valuable because they put so much effort into keeping it alive and reproducing it. But it's actually the opposite. The most valuable creature is the one that's no problem. You don't have to do anything to it. It'll reproduce on its own if you let it. And that if you wanted to kill it, you'd have to work at it. Yeah.
It's funny because there's a lot of reptile keepers that think the opposite. They think like if you make a hybrid, that's weaker and that's
No.
not as good.
It might be if you're doing some of the really crazy things they're beginning to do on really distant stuff, but that's weaker means chromosomal misalignments, chromosomal mismatches. Where things didn't hook up right. But like even the anaconda boa cross, what they call those boacondas, I think those are pretty viable. So that shows that eunectes and boa are not that far apart. Some of the stuff that's really far out where you do see problems, I would say that I don't care for that. I don't see what the point in that is. Now, what is good about that is the knowledge that it can be done, because that does infer a lot. That tells us a lot about the actual genetic distance of two organisms. you know so if you've got two types of snake that cross and you get them to cross and you have problems with the offspring and there are clear problems, that means those two are quite far speciated, and yes, they can cross, there's still some relation, but they're quite distant. But when they're crossing and you get 100% viability and 100% reproducibility, and they're strong or stronger than their parent species, there's no weakening there at all. The weakening comes from chromosomal misalignments from distantly related stock.
A lot of it is like looking at like papers about what happens in the wild and there's loss of fitness, and like that's in relation to the environment and those exact pressures, because you're moving it and you're making it less specialized. But captivity is a different game, unless it is the animal that is like you cross it so distantly related and it comes out absolutely screwed, then you just cull it and you don't repeat that pairing. Like you're in control, like I said earlier, you're in control of everything.
Yeah, exactly. You just you document that, you publicize what you've done and the results. You maybe keep that one animal alive if it's viable, but you don't reproduce those crosses. You say, we know this doesn't create viable potential. It's a waste of time. It's a waste of breeding the snakes to do it. So we're not going to do that anymore. And we're going to focus on these things that are viable. But just like you said on the last podcast that I saw, the one you did by yourself on hybrids, this is all just inevitable. There's no way to get around it. Ecological destruction, shrinking wild populations, the inability to bring animals in out of the wild, means that the inevitable future, even for the pure lines, is domestic. There is no other future for them. And there's going to be a point where there's so much going on with hybrids and there's so much going on with morphs that they will end up taking over. I mean, how many people keep jungle fowl now? A lot of people keep chickens, you know? Um, I don't know many people who grow species daylilies. There's some, you know. Most people grow garden hybrids. So there's a point where where you have a small group of specialists who keep the more specialized or the more nature focused, but most people are going to go over to the bright, the flashy, and the easy. You know, I mean, always they're going to go to the high dollar. You know, there's going to be that whole group of people that are going to go to the high ticket. There's going to be that whole group of people that just want the pretty and the flashy. They're going to be the people that want the easy to keep. And in time, the lines that provide those things are going to supplant the lines that don't. There will always be probably a few people keeping, you know, their Okatee corns and their Miami corns that, you know, they think are pure, and that's fine. They'll eventually peter them out and have to bring in a corn snake, and they won't know that corn snake, you know, even if it came from the wild, has a little bit of eastern milk snake in it, and theirs always did anyhow, or whatever it has in it. Um, Lines will do one of two things. The people breeding these pure lines will either run them into the ground until they're non-viable and they lose them, or they will eventually outcross to something. Now, what that something is at their discretion. But there is no way to keep, especially where you see a line starting to show an aggregation of deleterious genes. That line is going to have to be, I call those salvage crosses. There comes a point in every strain's life, every line has to be salvage crossed if you've inbred it poorly and not taking care of its genetic health, you know, over time. And that's just kind of what happens with them. There's no way around it. Um, yeah.
I always have this conversation where they're like, "Oh, it's all going to be mutts, and we're never going to see like pure Okatees or this and that." And I'm like, "Okay, cool. Like, what do your animals look like?" Because I don't keep them. I'm like, "So why are you bothered then? Like, you
Right.
didn't, if you not even had them to keep them and look after them this whole time, you didn't care for them in the first
Yeah.
place, and that's why things get lost. Because when it comes down to it, people like saying, "Oh, I like to see that it's still there," but
Hmm.
you don't own it. You don't like it that much.
Yeah, take a picture. That's what I say. Um, but here's the other thing. The Okatee phenotype will always be there. You may lose that specific inbred half-dead bloodline that you think came from Okatee, North Carolina, but the phenotype will remain because the phenotype is beautiful and people are always going to want it. And how can you escape what is? How are you ever going to lose blotching in any of the big three? Does anyone really believe for a split second that everyone's suddenly going to breed out Okatee? I worked with Okatee a lot. It's my favorite. But I just consider it a phenotype. You know, I also prefer pink and lavender and daylily flowers, and I like red mutations and chickens the best. But those are just arbitrary. That's an artistic taste. That's artistic license. What I know for a fact is when you cross these Okatees, say you cross and make a jungle corn with Okatee, and you've crossed it to whatever king snake, usually a cow king, but whatever king snake. Um, if you take that F1 back into the Okatee, it's hard to tell that you've got any hybrid in it. You know, certainly if you do it one more time, you've just got Okatees again.
Yeah, I mean,
Behaviorally,
again, it's the paint,
visually.
isn't it? It's the red and blue,
Yeah,
purple back to red again. Anyway, so it's like what
yeah.
I said in that last one, where I said like the obsession with the locality, but it's you're drifting away from it anyway. So these are like an avatar of what you think it is. So what's the
Yeah.
difference between you take something out, it comes back in, and it still looks like the avatar because your avatar isn't representative anyway. So the things that people are obsessing over like don't exist.
Yeah.
But even this
Yeah.
whole podcast, people will watch this whole thing and still not get it. And there'll be a comment and be like, well, actually, they'll all be lost. And like, you didn't watch the podcast, did you?
Well, they think because a phenotype exists currently in the wild that it has always existed. As you said earlier today, people have a hard time conceptualizing geological time. And when we're talking about these corn snakes, did any corn snakes exist 12,000 years ago? I mean, probably, but what did they look like? Did they look like the Oketes? We don't know. There's no way to know. Um, the phenotypes that we know from the wild are what exists at the moment. But nature is not static. They are still evolving. We are accelerating their evolution because of habitat destruction, and they evolved from something else. So, yes, there will be a time when the Okati will no longer exist because there will be a time when the planet no longer exists. And unless Elon gets us to Mars and we've taken Okatis with us, how are you going to wild release the Okatis on Mars? You know? I
So
mean,
as a
so
hypothetical, like imagine some world event happened where melanism was like the perfect thing for across, and it spreads across the entire US. Everything's black, and people in the future
mhm.
are like, "Yeah, our snakes are black." And then something happens where the conditions change again, and it wipes back, and it all comes all striping. They would be like, "Ah, but we've got stripes!" Like it's
Exactly.
because it's just what they
Well,
know.
this goes back to the old problem of the belief that species are static. And then the even more silly belief that breeds are species and therefore static. I tell people working with breeds all the time, breeds are not static, they're not real, they're a made up ideology. You believe they exist. Yes, you can make a stable gene pool that reflects all of these phenotypes and you can call that a breed, but the breed is just an arbitrary collection of homozygous genes. It's the same in the wild population, but just because they're homozygous for those genes doesn't mean they're not carrying other genes that can emerge under the right situations. These species were never static, just like breeds were never static. They change over time and they can change as the environment changes. So, what people have to get out of is the static thinking that a species is an absolute stable point in time that is an absolute. They're not. They granted they've existed your whole life, but your whole life is the blink of an eye to the geological time that this clade has existed within, and they're constantly changing within that. And of course, the North American colubrids are the very best example of that because we know that they were no further north than at best maybe mid Georgia for much of the Ice Age, in the eastern half of the United States. And everything north of that has repopulated after the Younger Dryas and has morphed back into the forms that fit those environments. So they're just not real things. They're they're temporarily real. They're real under the pressure of a given environment. They're real if you select for that, and you're welcome to do that. But that doesn't mean everyone has to do what you're doing. What people need to start to do is to say, I have chosen to select for the phenotype of the Okeechobee milk snake, king snake. Now, the Brookside king snake, or I've chosen to choose to select for the phenotype of the Okatee corn snake, or I've chosen to select for the Mexican black king, for that phenotype. My king snakes are of this phenotype because that then reflects reality more. This phenotype arose in the wild, and you've chosen to continue breeding it. But here's the thing, this notion that if you outcross it, it's no longer pure is complete and utter bullshit. It is just not true. And there's going to be a point where you're going to have to outcross it to save your line. You're going to have to salvage cross if you let it get bad enough. When the smart thing to do would be to have an augmented line or a secondary line that you can bring in. And what you need to do is figure out what the genes that make up the Okatee look are and how they function. So let's say with a black king, if you outcross a black king snake to a speckled king snake, what do the F1 look like? And if you cross F1 with each other to make an F2, what's the segregation? And if you cross it back to the Black King, what does the BC1 look like, the back cross one generation? That's where you're going to gather the information that tells you how the full melanization gene works. That's also then conversely going to give you the information that tells you how the speckling factors work. so that you can then go back and forth between one or the other, so that you don't have to be stuck with, oh, but I've got to breed a black one into my blacks. No, no, you would be better off actually going out to a speckle or going out to something more distantly related, because maybe all the blacks descend from one pair of blacks that were brought into captivity,
Basically, you learn how to
especially.
recreate it, down to its core
Yes.
components.
Yes, that's the art of breeding, is knowing how to recreate the phenotype. You don't lose the phenotype. Poor breeders, uninformed breeders, breeders who don't know what they're doing lose phenotypes. We have this problem in daylilies where they apparently don't know that recessive is a thing. So if they breed something and it's recessive, then they say, oh, well, I lost the so-and-so trait. Well, did you try back crossing? You know, of course they didn't. They lost it, so they couldn't go forward. They often also only want to get something in the first generation. If they don't see it in the first generation, they're done. They don't go any further. A lot of breeders are like that. So if they make a cross and the first generation doesn't come out exactly what they want, they're done with it. But you've got to go 2 or 3, 4 generations to start seeing all this stuff lining back up. And the key is to learn how to remake them. How do are they reconstituted? When you outcross it and it is lost in the first generation, how do you get it back? How many generations does it take? That also then will tell you how many genes you're dealing with, how many major and minor genes. And once you have that working knowledge, you can kind of map out outcross these salvage projects. When I developed my daylily program, I knew what I was going to do going in, and I used the genetic knowledge I had from all the other work I've done to formulate what I was going to do. So I set it up on a 20-year arc in 4 5-year segments. I'm now in the third 5-year segment, and it is following exactly what I projected, or if anything, moving a little faster than I thought it would. Um, Now, that's not to pat me on the back and say, oh, what a genius I was. It was just that I kind of knew what it was going to take based upon what I projected the genes were. Now, I projected it taking a little bit longer. Some of the things that I wanted came out quite a bit quicker. And then that was another thing that all the daylily people told me early on was, oh, if you outcross back to species, you're going to lose all the good fancy traits. You're never going to get back to them. It'll take you 20 years to ever see X, Y, and Z again. And I thought, I seriously doubt that. And of course, it didn't. I've got stuff now that are like a quarter species, that have a species grandparent or one of these near species based grandparents that are right back to the full fancy look that you could not tell that they are, except that they're on bigger, more vigorous plants that are way more fertile. That's a problem we see in the tetraploidy through the colchicine conversion to convert them from diploid to tetraploid is with the chromosomal misalignments. You see a lot of fertility issues, and a lot of these plants won't set pods or set very poorly, where my plants set pods heavily. So I can see the species traits I wanted, but now if you just look at these plants, you're seeing a fancy garden daylily. But it's going to have a much wider gene pool, and it's going to have these stronger traits. So I kind of mapped out that program based on my knowledge of how you do something like that. So once you know how a set of genes work, you can then kind of say, okay, this line of black kings are starting to get too inbred, and that's starting to be a problem. And I've got to outcross and say, maybe you're in the UK like you all are, and you can't just go out and get another one because they're all the same exact line. It's not going to do anything. Well, if you know how the genes work, then you can go to anything else. Preferably if you want to stay kind of, within kings, you go to a speckle or you go to a chain or you go to whatever you can get. The furthest it would be the best. Californian speckled would be the closest. If you could go to an eastern or go to a Florida, go further out because that's going to open your gene pool wider, give you more gene integration. And then, this is going to take 5 years to get back to the fully black phenotype. They're all king snakes, you know. I mean, if you want to be technical, you could maybe stay on the types coming from the west of the Rockies, because those are going to be closer related. Those are going to be closer in background genes. But if I were going to do it, I'd go further out so that I didn't have to do it again as often. The further out you can go the first time, the longer it will be before you have to go in because you've opened the gene pool wider. The wider you can open the gene pool on the first lick, the better it's going to go because it's going to take longer to get back to that high point of inbreeding again. So those are all considerations for why, you might would outcross and why you would Why you need to know the genes and look at these as phenotypes. You can return to the phenotype. Sloppy breeding can lose a phenotype, but well thought out orchestrated breeding will not lose a phenotype. And we know that they can be kept and not lost, or they wouldn't exist in nature. The southern refugia of the Ice Age proves that to some extent, I think.
I think herpetoculture in general tries to reinvent the wheel, and what I mean by that is
Mm-hmm.
in other cultures like goldfish, aquatics in fish and like birds and
Yeah.
stuff, we'll say like line breeding, we'll say breeds, and then with reptiles, some people are like, oh yeah, line breeding is made up, or
Mm-hmm.
and we've heard that, haven't we, Ali? And then it will be like, oh, well, if line breeding is always bad because it involves inbreeding, and therefore they always end up as a crashed dead population because inbreeding
Mm-hmm.
always, always leads into that. Or it'll be things like we're starting to say things like designer green tree pythons rather than just saying breed. So
Mm-hmm.
why are we trying to reinvent the wheel? Because we want to be different and extra, rather than that this is the
Yeah.
terminology we've used for domestication for like thousands of years. Just get on board.
Well, but don't you think most reptile keepers and breeders really like to see themselves as outside the box and on the fringe, and so they're trying to present themselves as really unique anyhow? And it's like
Yeah,
these aren't domestic animals; these aren't like those stupid old chickens and dogs. I keep snakes; they're cool, man.
that
It's
is
that.
it in a nutshell, I think.
It's that, and then you've also got the factor of, well, I'm a conservationist, I'm a scientist, I have no degree, and I've never done any conservation. I wouldn't know a wild species if it bit me, but I'm a conservationist. So there's a pretense. There is a what am I there's a pretension with
Yes.
it, I think. Yeah, that's the problem, really. Because yeah, it's not. I would say they're already at the point where there's not much difference in the snake breeders and dog breeders and chicken breeders, or goldfish breeders. They're certainly not going to be in another few decades, another century. It's going to be exactly the same. And goldfish are my other big thing. I've not spoken about them much. They're off the hook fascinating because they're tetraploid. They have 4 strands of DNA. So their segregations are just crazy. And it was working with them that made me want to work with the tetraploids and the daylilies. But I'm not going to go off on that tangent. I will spare you. Goldfish are something I could talk about for 25 hours straight, and you would die of boredom. But yes, there's all of. Okay, line breeding. That's something I want to touch on. As you were saying, line breeding. People think line breeding means taking a pair of full siblings from a line and breeding them forever in perpetuity. That's not line breeding. That's genetic suicide. Line breeding is where you bring together 2 or 3 or 4 distantly related or unrelated lines and you weave those together. That's real line breeding. And then you make a line out of them that comes, see, and people do this in chickens. Like the old breeders back in, like, say, the early 1900s, who really developed a lot of the really fine lines of production fowl, they would bring in birds from everyone when they started. And then they would bring in maybe 2 or 3 different breeds other than the breed they wanted to breed. And they would start blending those and they would make different lines. And this line does this, and this line does this, and this line does this, and this one over here does this other thing. And then they would start gradually bringing those lines together until they ended up with their own distinct line that was genetically stable and had an open enough gene pool that they could then just breed their strain. But even at that, they would make family lines where it was never just, even if it was the single sire phenomena, even if there was like one exceptional male they used, they would breed him over a multitude of different females and they would establish a family line out of each of those females, you know, so that you had different lineages, so that you always had crossable lines. Now, one of the big problems for us as modern people is the expense of keeping the number of animals that's required to actually do proper line breeding. That's one of the reasons I actually went over to plants. Is it's just so much easier to keep multiple lines of plants. It's so much cheaper and easier and less space and less work. And they never chase you or throw dust on you or attack you or bite you. So that's kind of they're my retirement program. But it's hard to keep enough animals in the modern world, no matter what animal you're working with, to actually keep functional lines. So the way we have to do it in the modern world is that multiple people sort of pool together and sort of make like a breed association so that they can trade stock back and forth. But if all of their stock all derives from the exact same source, there still may not be enough genetic viability to make that matter. That's where what's going to matter in the long run is doing what would be called in plant breeding wide crosses. A wide cross is where you go to something very distant. So, like for me and daylilies, that was going back to the species. They all come from the species, but the main species I used, the clone of the species I used, was never used in the modern daylily development. So it's brought in a completely fresh batch of genes. And then the others that I used, although they are tetraploids and do descend from some of the conversion, um, they are not representative of the typical gene pool. So with these wide crosses, that opens up the gene pool and allows you're going to have to inbreed to set type. Inbreeding, you can't set type generally without some level of inbreeding. All breeds derive from inbreeding. And inbreeding's fine if it's done wisely and you don't have those deleterious recessives. You
I think
know
that's
your line
key. I
is
think
strong.
people don't
Yes.
realize that it's just like removing things and locking things, making it homozygous without deleterious things if
Right.
you can. And
Yeah.
hypothetically,
Yeah.
it's never going to happen, but hypothetically, you could inbreed and have the perfect scenario where there's not a single deleterious allele and it's the healthiest animal ever because of inbreeding.
Absolutely.
So inbreeding
Absolutely.
itself as a process isn't negative. It's
That's right.
the mechanisms and how you do it.
That's exactly right. Inbreeding is bad when what you're inbreeding are deleterious recessives and they start to emerge. That then weakens the stock. But I believe that in the future with gene testing, we'll be able to take a line and just type it out and know all the deleterious genes that are there and probably even silence them or remove them to some extent. We're a few decades at least out from that, probably centuries out from it being really efficient and being really available, you know. But I'd say a few billionaires will be able to do that in a decade or two. Um, and that's going to overhaul how breeding is done. But in the meantime, that's why test mating is so important. Test mating, for test mating, you use inbreeding, but depending on the results, you either discard or proceed. So that first test mating is not a foundation. It is simply a test to know if you're going to be able to or not. If you're then going to be able to, the sky's the limit. Go for it. But even if sky's the limit and everything's good and you don't see deleterious and you can proceed with inbreeding if you want to set a trait, at the same time, you need to make a branch line or two that is that same line outcrossed to something more distant. How and the more distant you're willing to go, the better. Really.
Yeah, I think people, the bull pipe, the morph people, I think, are the ones that like could jump on this and get it quicker. Because the other
Yes.
way to explain it is like, okay, so a deleteless recessive allele. Imagine it's just like albinism, right? And the goal
Mm-hmm.
is you have to do a test pairing to see if an albino pops out. And if the
That's
albino
right.
is what you don't want, then you have to cut or change founders and things like that. And just basically, what you're trying
Mm-hmm.
to do is either cover up with heterozygosity the
Mm-hmm.
albinism or remove it entirely so your population is homozygous without it.
Mm-hmm. Yeah, exactly. Reptile breeders have been doing test matings for years when they establish the nature of genes. And, every major gene that I know of has had a test mating period where they determine if it's recessive, if it's dominant, if it's genetic, because as we all know, there are instances where we'll get this morph animal and then it's not genetic. It doesn't pass. It never shows up again. 3, 4, 5 generations later from known descendants, you're still not seeing that look again. And that's just a chimera of some kind. So reptile breeders know how to test mate. They just somehow have not made the ontological leap from test mating to test out a specific gene to test mating to test out the viability and fundamental soundness of a line. And that's an important leap. But yeah, I don't see how it would be. And I'm not to say I don't. I want to be clear. There will be someone in the comments say, "I've been doing this for years. How dare you?" you know. And congratulations. I couldn't be happier. In all sincereness, I know there are probably some people doing this. I do not think everyone, is problematic. Um, but I just want to, explain how this is done and stress the importance of doing it so that people that don't conceptualize this can put it into play. I'm sure there are some people doing it. Certainly, stuff like this is being done in conservation breeding in zoos, and a lot of my ideas about how you work with expanding a gene pool come from that early background working toward conservation genetics. A lot of my ideas are very based in that kind of stuff. Okay, now something I wanted to ask you all before we go any further is what because you all will know more about the hybrids that are actually extant in the hobby than I do. What things do you all find exciting? Like for yourself, what are you getting excited about in hybrids and you know give me some feedback on what you all see as interesting and exciting out there or within your own projects.
So what I would like to see is like a really colourful animal that's really bold, that is
Hmm.
interactive, that is cohabitable, that doesn't have like issues with like eating each other, where they're really easy to
Hmm.
start as babies.
Hmm.
They are
A lot of
base
eggs.
a lot of eggs, yeah,
A lot of
just like
eggs.
really easy, but then also everything you want in a pet snake.
Yeah, yeah, absolutely. And I say a lot of eggs, as much for the sellability, actually more than the sellability, is for the ability to get enough offspring that you can do the gene segregations you want to see. You know, the more offspring you can produce, the better a chance you have of getting these multigenic combinations in a homozygous state. So that was one of my considerations with the corn as the base for my project, was because I could see more offspring and that way I could make more selection, or in my instance, I could make better inference. But I think that would be a good thing to apply to any breeding program. Fertility, viability, egg production, because the more offspring you can see, the more you're going to get to your goals faster. But go ahead, tell me more about what you're interested in doing.
Things like leucistic Texas rat snakes, they are like that
Love
pure
those.
white snake. But in the
Yeah,
UK, they're all like het for scaleless, or they've got like really bug eyes. But
yeah,
a lot of people think that the bug eyes is linked to the leucism, the gene. But I'm like, is it,
could be.
or is it just like that close? So like crossing that out to something completely different,
Hmm.
playing with that to see whether it's you can bring back the leucism without the eyes, or
I wonder if the eyes don't have something to do with them being related to something like the Trans-Pecos rat snakes. I wonder if it's actually a deleterious or if it's not just a throwback, an atavism to something in their ancestry. Because if you look at their eyes and then you look at the eyes of the Trans-Pecos rat snake, they're almost identical. Just a thought, just just an
but if you were
abstract
to
thought that.
cross, let's say that to
Hmm.
like something else, and
Yeah.
if you work out the simple recessives of the leucism, you can get the leucism back
Hmm.
out, and the eyes don't come
Without the bug
back.
eye, yeah.
Yeah, then you
Yeah.
know that maybe they're not linked. Then
Or even if it is that you just separated it, because
yeah.
just it doesn't necessarily mean that it's the one gene coming. It's not pleiotropy, in other words. It may not be pleiotropy. It may be something like a linkage, and if you can break the linkage at the chromosome, you can get rid of one aspect of the phenotype while keeping the other aspect. So yeah, that would be a great project. What would you think to outcross them to?
Probably corns.
Yeah, I think corns aren't there. Do they have leucistic corns yet? Or I'm sure someone has made that.
The closest we've got is the palmettos, which
Oh,
are
right, right.
the red spots.
Yeah, and they have that weird head and eyes too. Have you
Yeah.
noticed that the palmetto have the small, real angular little pinched head and the bigger eyes?
Mm.
So that's interesting. There could be a pleiotropy there. You'll know if you ever do the outcross. Um, if I were going to outcross them, I would outcross them to something just absolutely huge, and I would go way out. I would take them to like a dark phase, Pituophis of some kind. Get something really big. Um, and Pituophis have a different head morphology that would be really interesting to see if the different head morphology might take care of the eye issue as well.
Mm.
But
The
yeah, I
leucistic,
love the leucistics. Yeah.
yeah. I'm very much like monochromatic. I like jet black, evident by all the
Yeah.
MBKs, and then I like pure white, like just yin
Yeah.
and yang, basically. Yeah.
Yeah, I really like that too. I also like what you see sometimes in like the Imperial Puebloans, the solid red. You know,
Yes.
of course
Yeah.
they'll have the black and the white on the head usually, but I'd love to see those, and I think they can selectively breed those up to where they have just a solid red snake that looks almost like those gorgeous red spitting cobras.
Yeah. I think a lot of people are
Yeah.
just playing with F1s because they come out crazy, right? They're just enjoying doing random crosses. But I
Oh
don't think
yeah, and it's
anyone's going and
fun.
being
It's fun.
like,
I totally get that.
what's the next
Mm-hmm.
breed? But I think people are only just
Right.
starting to think about it.
Mm-hmm. A gene I love that occurs in some of those South Florida phases of the king snake is the anarthristic that goes blue. Have you ever seen those?
No, I haven't, no.
They're gorgeous. The Anary brooksii king snake are stunning, and as babies, they're quite bluish. Um, Something I would love to see selected up too is I think they'll eventually find a mutation where they end up with blue anaconda. I mean, because when you
Maybe,
look at
yeah.
them, there's variation in the anaconda, the green anaconda, as to how green they are. You can't have green without some kind of blue pigments. So there's some kind of blue there. I think in time that's something they'll end up morphing out to. But I have a thing for blue. I love to go bluish, lavenders, things like that. One of my favorite morphs in the corn snake were the Anery hurricane motleys, which of course hurricane motley is a polygenic. You know, motley is a single gene, but then to get onto those hurricane blotches is selective breeding. That's modifiers. Um, and you would see those that would go almost lavender, and they were really pretty. I really like these bluish and lavenderish, silvery kind of colors. And I think something like that in self-colored snakes, like you're talking about, a gene like that that would turn a black snake into like a almost a blue, almost like a blue cat. I don't think any of the North American colubrids will ever go into a true blue like those sky blue tree boas and pythons, but I think you could get quite interesting silvers and things like that out of them as well.
I saw. Do
Um,
you ever see an animal that you didn't get and then it haunts you to this day?
oh, so many times, yeah.
I saw a corn snake in a shop I worked in. It was like this purple.
Ah, yeah,
And then, but it was just when I started getting into reptiles and I didn't know anything, and I was like, oh, that's probably like a morph that I just don't like. I was like, it's probably loads
right,
of them, right? It's just a morph. And then they took it and traded it at a show, and then because they were like, it's just a corn snake, and I've
right.
never ever seen it again.
That's amazing. Yeah, things like that. When you find these unusual animals, there's often something there. Sometimes it's not, but it's certainly always worth trying. And you just want to try to go to your F2 or F3 and see if it's going to come back out. But yeah, I think there is a load of potential for purples and lavenders. I love the idea, like what you like, of self-colored snakes that are just one solid monochromatic color. I think that's stunning. I just on Facebook saw a leucistic reticulate python that was just stunning, snow white with black eyes. Um, and I love that. I love solid black. But I also think that there's so much potential within all the patterns. Um, I think that when you start combining patterning morphs, so like the motley morph, I wonder what that's going to do if it's homozygous with homozygous banding. I mean, what are and I wonder if something like the milk snakes that have just the where the band is broken down to like a circle down the back. I wonder if that isn't the Motley mutation. And then another thing that we all know and talk about and whisper about is that how many of these morphs are actually deriving from hybridization, you know? So you've got two things. Morphs in captivity could have a captive hybrid derivation, but morphs in captivity could also be coming out of the wild stock, which in its of itself may have some hybrid basis to it. So in other words, because these are all so related, there could be individuals of any of the big three of the North American colubrids that carry the same motley gene. Just like we know that the albinism gene is similar in most of them. There's two different ones. I think, what is it? The is it the cow king and the corn that their albino is compatible, but then there's another albino that's not compatible?
Don't know because albinism. I'm just like, yeah. So I just have not
Yeah.
learned it.
Albinism's not my favorite either, but I remember that there are two different albinisms
T
in
positive and T negative, isn't it?
well, there's that, but there's also just there's two T positives. I know that there was something where you could breed the albino cow and corn and they are compatible, and so you get albinos in the F1, but then I think I'm wanting to say it's out of the milk snakes, maybe, that their albino mutation for T positive is different than the corn and cow version. But I'm probably just pulling that out of my backside. But I know that there is something like that with the A male mutation. There's two versions. There's two of the T positive. Then there's also T negative. And those make something different. Um, but I'm with you. The thing I like about the A male mutations is that they can really bring up the red, but then I don't like the black the red eye. I prefer a dark eye. And I always thought that the better way to go is just to select down the melanin and select up the eumelanin, or the no, select down the eumelanin, select up pheomelanins, and select up the erythrophores. I mean, basically hypomelanism, I think, is a better way to get to those high reds. And then another way is like what we're seeing in those Imperial Pueblans, where whatever gene is causing them to not be patterned, so that you just get a solid red snake. I don't think that is hypomelanism, because there's black on the head of most of them.
Mm. That leads me to something I was going to mention. Yeah, because
Mm-hmm.
I was talking to Matt about, well, why don't you do something with the Imperials and like go and make a breed and a breed standard, and like they act like this, the head shapes like this, and just
Mm-hmm.
take them in a whole new way. But he's very much like, well, I didn't coin the name Imperial and I didn't start it, so like I have to pay like homage to what it already is and stuff. And I'm like, but like if you that's a
Nah.
very like that's a reptile brain, that is. When you think about it in
Right.
dogs, every single dog breed starts with another breed. You take the traits from that breed, take it into a new line, and into a new breed. That's exactly how it
Yeah.
works.
Yeah. Yeah. I'd say nah. Everyone throws a breed name on it. Just throw a breed name on it. Who cares? Say I developed my breed of blah 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 from Imperial Pueblans, but after his selections are beginning to not look like the old Imperial Pueblans anymore. You notice he's beginning to get into the later generation phase. You notice he's making selection towards specific things, and as he seems to be making, or at least what I'm seeing on his Facebook indicates that to me, as he's making those selections, it seems that he's moving a little bit further away from just the old Imperial, kind of pretty chaos look. And of course, as he keeps breeding, if he, for instance, starts with Imperials, and I don't know if he's still making F1s as Imperials or if he's now interbreeding the Imperials themselves. But if he's beginning to interbreed the Imperials themselves and make the later generation hybrids, he's going to move away from what the Imperials were anyhow. It's going to become his own thing. So there will be a point where, even if he doesn't call them anything other than Imperial Pueblans, other people will call them, his line of Imperial Pueblans. They'll end up with his name on them, if he keeps selecting. I mean, because that's what happens. You can look at some of these lines that have people's names attached to them. I don't remember right offhand, but you used to see like, uh, there would be the this person's line of so and
Applegate,
so,
yeah,
or the
things like that.
yeah, 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 exactly, that kind of thing. I'll tell you another phenotype that I really like. Is like the Miami phase of the corn snake, where you've got more of the gray background and more of the red blotches. I think that could be selected up to be as bright and striking as like the gray banded king snakes. In fact, I think it's basically the exact same genetic setup. So I think that even without going hybrid, even with just selective breeding, you could within a lineage. Now you wouldn't want to stay locality Miami or whatever, but even if you did and wanted to select for color, in other words, there's so much range as people start domesticating, which is what they're doing, whether they want to call it that or not. to start selecting for these phenotypes and really go to extremes with them. So, like when you look at a Miami, don't think of that as the end point. Think of that as the beginning point to get to something even more extreme. That's what selective breeding allows you to do. You know, so like, let's say for instance that no one had black king snakes there in the UK, but you had speckled king snakes, and some of them didn't have much speckling. Well, you could take those and select through them, and eventually wind up with the black morph of it. Black version. So it's the same. What I guess what I'm trying to stress is with any of these big three North American colubrids, if it exists in any of them, and you have a version in another species or whatever you want to call it that's similar, you can probably select up to that in time. If you apply selection, you bring in animals that are already going that direction and keep selecting for cleaner and clearer. But another thing is if you've got a line that's really set and every offspring comes out the same, you're probably not going to see that. And then the key is to bring something else in. So you could bring in a gray band or, put a gray band male over a Miami corn female if you wanted to go the hybrid route and do it. Or you could bring in a corn snake that has a real light background, you know? So there's a lot of avenues to get to these things, and that's all selective breeding. Um, there's so many morphs out there that I think are still potentially to be made that are not single gene morphs, but that are complex, multigenic, polygenic, quantitative traits that would arise through selection. Like the blood corns, those are fairly polygenic because F1s don't come out. It's a little dominant, but then you have to select to get the fullest expression of blood corn, although those have health problems. And I don't know if the health problem is a pleiotropy with the gene itself or if it's just that they've inbred the line to death.
It could, yeah, it's hard to tell, isn't it? You have to outcross to find out, I suppose, to figure out yourself.
Exactly.
I always think of like people that like they get bored of something that they're working with because they've worked with it for like 18 years or something, and then they just drop it and go get something else. When you're thinking of lines and hybrids, what you've got now to what you've got in 18 years, it would have changed. It's a constant like program rather than this like same thing of just reproducing it. You're like
a
working on
constant process of refinement, yeah.
refinement. Yeah, that's the word.
Yeah, and then once you get it to a point where it's stable and they don't change much after that, and the refinements become very small things, we'll start outcrossing it and see what else you can make with it. I mean, that's the beauty with the hybrid. You can go back to a species, you can go back to a subspecies, you can go back to another hybrid line. This is what's going to be so exciting in the future. And I want to throw this out. I see a future where there are all of these breeds made from hybridization and made from like locality looks or pure, whatever you want to call it, non-hybrid domestic breeds that have been selected up to these high levels of selection, at which time you'll be able to do what I call with daylilies or with chickens, gene shopping. You want a mutation? Well, then you just go wherever it exists. You are breeding this, say you've got this hybrid and you've been breeding it for years and it's now stable and you think it'd be really cool to add blue eyes and leucism. Well, then you go out to the rat snakes, or if you've used those rat snakes over whatever else to make a good line of leucistics that don't have the eye issue, then you would cross that in and you could make a line of your breed in leucistic. People do that in chickens. The very best breeders on earth for that with the chickens are the Germans and the Dutch. Every breed can then have 100 varieties that are different color forms of it. So that's what reptile breeders are going to be able to have in the future. Like right now, everyone's still looking at it in the sense of species and species morphs. And then there's hybrids that are this dirty thing over here like porn, or, or corn. I think that's what you have to say on YouTube now. But yeah, it's like this dirty thing over here, this dirty secret. But in time, it's going to be these breeds derived from hybridization, these breeds derived from non-hybrid lineages. Conservation will be its own thing off over here to the side, and you'll be able to gene shop. You'll be able to pick and choose. So like python breeders will be able to they'll know what's compatible for breeding. They'll be able to go to like anything that they know is compatible if they want to bring that gene in. Colubrid breeders will be able to go to whatever is compatible to bring that gene in. Say that you have based your line in milk snakes, but you suddenly want your milk snakes to be 8 feet long. Bring in something that derives from Pituophis. find the biggest line of Pituophis you can find and cross those in. Bring that in. Now, you'd have to bridge it probably through something like a Florida King or a Chain King, but that's the beauty of it, you know? And it would be even better if you could actually go to a hybrid line rather than going to the more species-like non-hybrid stock at that point in this, fantasy future, where you could go to something that is a big hybrid deriving from a chain that you could, use as the intermediate. Those are like when I was doing chickens, and we would like take bantam breeds, which are really small, and blend them with, huge large fowl breeds. We would do intermediate crosses where you would take the tiny bird to an intermediate sized bird that it could breed with, and then you would take the large bird to an intermediate sized bird that you could breed with, and then you could breed the two offsprings, or the offspring of that could be taken one direction or the other. Some of the bantamism genes are dominant, some of them are sex-linked dominants. So if you did that right, you could transfer that bantam gene in the next generation up onto the large fowl. So there are all of these breeding techniques and breeding strategies. And let me tell you something else that they've done for centuries in poultry. The really knowledgeable chicken breeders have done this. Their whole poultry yard, they might have one breed and 18 varieties. Or maybe they even have 3 or 5 breeds, and each breed in 2, 3, 4, 5 varieties. But if you actually knew what they were doing, the whole thing was interrelated because they had bred everything together at some point. Okay. And they would know how to breed the different color varieties. So, for instance, let's say with game breeders, they would have like 18 color varieties. They would know which ones to breed to which ones to produce which ones. They would know which ones to breed to produce this trait, which
Which
ones to
paints to mix.
that's right. That's right. So that instead of it being separate breeds or separate varieties that all had to be kept in their own little boxes and never crossed, it became a box of crayons instead of, a pen and a crayon and a chalk that couldn't work together. They were all interactive things that could be used together. And the best way then that you could work with hybrids and develop these breeds and be able to create these breeding strategies where you would never have to deal with uh, inbreeding depression or these problems is by creating multiple different lines and crossing those periodically so that you would know how to interact and taking the best from those back into the one or the other parent side so that there's a little bit of genetic relation so that when you start crossing, you don't get all that weird background mismatch. If you have 5 breeds, even if one breed is huge, gets 8 feet, one breed is tiny, only gets 2 feet, one breed's intermediate, one breed's more kingsnake, one breed's more pituophis, one breed's more corn snake, whatever, they would all share genes. You've just selected them into these directions. Yes, maybe there are more genetics coming from one side or the other, but they're all interrelated, and you know how they cross. And so when you cross them, maybe your mid-sized snake is actually produced by crossing the giant and the small, because it's easy to get the small snake to breed the big female. So there's all these kind of things where you can create these breeding strategies that you don't have to have, 800 animals to keep a viable population. You can create like an interactive pool of animals in such a way that you never get bored. You constantly can create new things. You can constantly create new color varieties. You can create big ones. You can create small ones. You can create different, the head and neck forms, whatever you want to go with, scalation, rough scale, smooth scale, you know, um, temperament qualities, whatever you want to breed into them. What's in your stock, and so you can blend your stock at any point you want, and then you can also bring in other things and gene shop and bring in whatever you want, create whatever you want. Now, that's not quite feasible yet because you don't really have any set breeds yet. So everything's still a little more too chaotic to do this in a refined manner. But one of the reasons I contacted you is because I believe it's right at the cusp of being there. I believe we're right at the cusp where the people producing hybrids and the people with the non-hybrid select lines of morphs are right at the point of tipping over into being domestic breeds. And so I wanted to get this information out so that they had these tools and could think in this broader perspective about and get out of the box they've got themselves possibly trapped in right now, and start to thinking, well, what could my program become? Not what could this pairing become, or what could this cross become? What could my program become? And your program can become like a whole production unit.
Your entire
Where it
collection is
is a
your
production
program, not
unit.
just like
That's
Noah's Ark
yeah.
collection of pair.
Yes, yes. To where the whole thing is interactive. The whole thing is your colubrid program, or your boid program, or your python program, or your cobra program, or your rattlesnakes, or whatever it is you're doing. Because this is going to apply. We've not talked about venomous. This applies all the same to all of them. I know people making hybrids in those too. I don't advocate keeping them. I've never kept them, but
That gets
whatever.
sketchy because what does the venom do? Do you know what I mean? No,
Yeah,
I'm not
yeah,
playing with
exactly.
that.
Well, I'm not advocating it, but they'll do it. I mean, it's inevitably going to happen. But here's the other thing with the hybrid venomous. What if hybridizing venomous is a way to produce new drugs? I mean, because snake venom is being used right now in drugs. So what if combining, let's say that this snake venom does this and this snake venom does this, and they're both close enough that they'll breed and produce fertile offspring. What if you can combine those and get a super drug out of them? So that is one of the reasons I'm certain the venomous will be hybridized in time. Once they realize this, just like they hybridize plants to produce stronger coffee or stronger vegetables or stronger whatever, in time the pharmaceutical world will start doing the venomous hybrids to produce super drugs out of the venom, in my opinion. But that's a whole other ball of wax, and again, I don't advocate anyone keeping it, except working with that outside of zoological facilities. But with that said, whatever you're breeding, think of your whole program as an umbrella. It's all one thing. You can go in all these different directions with it and move back and forth. And in that way, you never have these worries. You never have worry of, oh my gosh, where am I going to get another of this to breed in? You're just going to go over here to this, and you know how the genes work. Or at least if you don't know how the genes work, you can figure it out pretty quickly, and you can bring them back. One of the biggest hindrances is that people lack confidence. They lack confidence that these things can be done. They don't know how to do it, and so they don't know what to select for. But the key is just to keep records of what you get, do those test matings, and then do 2 or 3 generations of test matings. You know, that's going to give you all the information on a mystery.
It's a whole new world. It's like that. It's like that analogy. As like it's like people think it's a glass
Mm-hmm.
ceiling. We've done it all, and the only like new
Mm-hmm.
frontier is like the technology and like the enclosures and how well we keep them. Well, the next step
Mm-hmm.
is domestication.
Oh, absolutely. We have not even begun to work with the natural world in the way it could be worked with. And a lot of people say, well, it's a natural, it's playing God or whatever. I don't care. Humans have always done this. Non-human species do stuff like this. Non-human species manipulate and farm. We don't realize it, but they do. There are ants that farm algae. There are, various species that farm each other. Um, so this is just it's nature. You know, you can't get outside of nature, and we have brought the natural world to a point where it is we are in the process of causing a mass extinction. And the key, I think, to getting out of that is not just conservation, because where are you going to conserve stuff if there's nowhere to conserve them? The key possibly for the future is when you have huge swaths of the earth that are possibly deforested and depopulated of their native species, there may be things that we have in captivity that we would never think could work in the wild that will go back into the wild. And I'm not saying necessarily in the conservation sense, but just in the sense that if you have wiped out the predators, one of our hybrid snake species breeds that doesn't have all of its wild instincts maybe could live in that environment if rodents had become a problem. You know? So we don't know what the future holds. And the thing of it is this notion, well, we've got to keep it all pure and not mess with it. We've already messed with it. We've already messed with it to the point we're past tipping points. We're past a whole lot of tipping points that we can never come back from. So we can never go back to the world as it was in 1700. That world is gone. It's gone. And so now we have to think about what's the world going to become. We're not going to slow down our rapacious appetite. We're not going to slow down deforestation. We're not going to suddenly preserve everything that's left. We're going to keep destroying. That's what we do. We're rapacious monkeys, and we are not friendly, and we're going to go out and keep destroying. So I think that it's just like feral chickens. There are feral chickens all over the world, feral populations of chickens. Well, people say, well, that's awful. Well, but is it? I see. I don't have this notion that non-native species should never get into an environment. Well, in the face of climate change, we may end up having to rely on non-native species to fill the niches we need in nature. So that's another thing to consider, is not just that we have to think in terms of all of this being in a plastic box, but in the sense that I suspect that within just a few generations, any domestic line can be rehabilitated to become feral.
But it's like trying to recreate aurochs from domestic cattle, right?
Mm-hmm. Exactly. Exactly. Yeah. Which, is a big ask, but they're certainly playing at it. But the thing of it is, I don't care if they actually recreate aurochs or not. What would be viable is to create a grazing herbivore that would interact with the steppe. That's what would matter. So it doesn't have to be an auroch. For my part, let's make it white part cattle. They're pretty, And that's the other thing. As an artist, the notion of a nature where everything is in technicolor, where all of the animals are as crazy colored as the flowers, well, nothing could be more appealing to me. And the notion that they can't survive in the wild is, they might not survive in every environment, but it also depends on how you stack an environment. You know, if you want grazing animals and you don't have predation and you don't want the predators, don't introduce the predators, and then you can introduce any color of grazing animal you want. You know? I mean, really, it's about engineering a lot of this. And, I don't want to sound too crazy and too out there or too like science fiction, but when you look at what nature allows, I mean, I realize that most of these bright red snakes are ground dwelling and dwell underground and are hidden. They're cryptic, but nature allows that. You know, you look at the coloring of a peacock, or even the coloring of the wild jungle fowl, or the coloring of a lot of these birds. They're bright. A lot of these snakes in nature are bright. Now, often that helps them to hide, but that doesn't mean that everything has to be brown. Okatee corn snakes exist quite fine. The bright colored ones right out in Okatee, North Carolina. I've seen them there. I've also seen them corn snakes that look different. They don't all look like that, but they can survive. And so that's the thing, is the selection for morphs, the selection for color forms, all of these things. Now, albinism, yeah, there are some of these genes that might not would do well in the wild, but yet we found the morphs originally of them in most instances in the wild.
Well, that's like the California kingsnakes in the Canary Islands. The entire population is albino.
Oh, really? I didn't know that. That's
Did you not know that?
fascinating.
No,
No.
no, the entire population is albino.
Oh, I can't tell you how much I love that. Are they striped or banded?
Couldn't tell you. I just know they're
Okay.
albino. That would have
Well,
been like some
I'll be
pet
hitting
ones.
Google.
Yeah, that'll be some
The
pet ones that
Gaulies,
started
yeah.
off and they've spread, and that was just the entire founder effect, isn't it? Basically.
Exactly. Well, exactly. Well, that right there goes to show you. That goes to show that's a perfect example. They don't have predation, I'm assuming, of any kind that's significant. And so those can survive in the wild there, and they've made a viable population. That's amazing. I love that. Yeah, I mean, I know a lot of people don't like it, but I would love it if everything was just in Technicolor. If everything just looked like an acid trip, you know. Um, and that was the thing that I always loved about morphs, is they're not unnatural. We bring them all in from the wild. We just protect them and preserve them. Actually, to me, breeding morphs is a type of preservation. It's a type of when I see these purists saying, "Oh, they're just those awful morphs. Well, they can't live in the wild." Well, they all came out of the wild.
Yeah, we haven't
like,
done any gene splicing or like modifications to artificially create
right,
it. It was just that
right,
you find it and proliferate it in lineage that always everything came from the wild.
exactly. Yeah, exactly. So there, you know, I like the question. How can you do anything outside of nature? Anything you do is nature. As abhorrent as that is, as abhorrent as the applications of that potentially are, um, but fossil fuel was there for us to access. It's natural that if we could use it, we would try to get it. You know, our distant ancient. I mean, you have to think what put us on our evolutionary path was probably chipping at rocks. Well, how far is it a step from chipping on rocks to going into a cave and digging ores to digging a little deeper in the earth to find fossil fuels? It's just a natural progression. It's what humans do. And I'm not saying that we, maybe shouldn't get on to better, cleaner energies or anything like that. But when I look at these things, even if they're destructive, it's a natural progression. Another thing that I know from evolutionary science is that when a species reaches its zenith, there's a point in the strata where you find its remains in high, high, high numbers. And then right above that strata, there's none. And, so that's a natural cycle. We see that it's most common with trilobites. And that's where it was first realized. But you see that with a lot of species. They come up, they reach a zenith, there's a lot of them, they're gone. So it's these natural cycles that things overpopulate and things reach critical mass where changes happen. These are all natural processes. So I've never understood these arguments against the hybrids based on it being unnatural or against morphs by being unnatural. Um, because anyone who is going to breed those morphs and breed them well should be breeding some non-morph animals for when they need outcross, or at least have access to them. And you should be producing some non-morph animals when you make your outcrosses. And this notion, oh, well, it's not good because it carries albino. Well, how do you know the wild-caught one that you're so crazy about is not also carrying albino? A recessive gene can travel unhidden through the genome of a species for tens of thousands of years and never appear until it meets the right match to come out.
You got to be test pairing your pure normals to see that it's actually pure.
Yeah. Yeah.
And they don't do
they're
it
not.
because yeah.
No. Now, they don't see it coming out because it might be 1 in 10,000 animals that carry the mutation. But if an albino corn snake was found in Gainesville, Florida, that means that there are other wild corn snakes carrying albinism.
Yes, there has to be.
Yeah. Yeah. And same with all of these. But, if in certain environments, any of these animals, any of these morphs can survive in the wild. And that Canary Island thing is just beautiful. I just love that. One thing
the
that I
native
used to
lizards are not loving that,
Mhm.
but
Well, yeah, I'm sure, and I feel bad for that part, but
but as an
still.
example of like how it all works and the founder effect and
Right.
stuff, it's like it's a perfect analogy of like how it all
Yeah.
works, right? This brings me into something that
Yeah.
I was going to do a solo episode on, but I really want to get your
Mhm.
opinion on. So I'm actually going to bring up
Sure.
a whiteboard. So this is how my brain has like talked myself through this. So I'm going to bring up a circle, right? I'll see what you think. So I'm envisioning, right, this generic pool as being like generic. This is all within North American, the big three. Let's say this is the big three, right? This is generic gene pool, and this is like ambiguous. You don't know whether it's pure. You don't know whether it's got a bit of something or other. And then I would say you've got your. I'm gonna make it smaller. You've got your like pure, normal, like the pure thing. There's then people in that camp there, and I don't have a point, I swear. And then you've got the locality, and then we've got the morph, and then we've got hybrid, and then eventually the breeds. But how I see it is, can you see my pen and everything?
Mm-hmm. Yes.
How I see it is, if your obsession with pure is that distinct, you should never be sourcing animals from here anyway. You should only be sourcing animals from pure. So it should be self-feeding into this, like this. And then what you do is have excess go into the generic pool because you sell the animals that you couldn't sell to the local pet shop, and they go and sell it, right? And then locality, locality can flow from there to that because they don't care about locality, right? It's just the species. But that shouldn't be. They should be sourcing from that. So this should be like this, right? This is like as inbred as it's going to get. So they're going to have to source from the wild,
they're the
like
closed
that.
circle.
Yeah. But then they're also going to go like this, right? But then morph will actually go from this because it's like, have you got the gene I want or not? And they will source, and that way. That's what I meant. And they're going to source from pure normal, and they're going to source from pure locality. And the hybrid is going to go like this, like this. And then it's like, I'll take all of it because I'm going to go for heterosis and then start going on my lines after. And then this will go from this. But you'll notice that if your obsession with purity, you should be never sourcing animals from this generic pool anyway. So if you're being as selective as you're supposed to be, it shouldn't affect you. And there's weird people that are like, has to be pure. But then what they actually want is to go source from some random pet shop, look at it and be like, looks like an oaky. They bring that in and they're like, I produce pure oaky. I'm like, you don't know that, like,
right?
And then even obviously, we and you are of the opinion of like it's all hybrids anyway. Like you can't pure. But if that's your mindset, and you look at how this all flows, like I don't want to understand why you're so upset about it.
Yeah, exactly. I agree. I think that's a really good analogy. It's a good graph.
Bit messy, but
another thing that graph clearly shows is that the hybrids and then the breeds deriving from both the hybrid and the generic gene pools and the morphs, so these three over here, generic, morph, and hybrid, because they have so much potential inflow coming in from every direction, and especially the hybrids. What that means is that those three areas should become the strongest. The emphasis on them should be the strongest animals, the best bloodlines.
And before I drew this is exactly your point you raised as well. It was that the morphs and the hybrids are going to be the future of it. And
that's right.
I hadn't even realised that when I drew this, and it's like I've actually just detailed that.
You've detailed it. And the hybrids then should be the best of the lot. They should have a gold star because done properly. Now I'm not saying they will be because I know humans, but done properly, the hybrids and the breeds that derive from them should be a step above anything else with the best temperaments, best fertility, best reproduction, best health, best vigor, best everything, most interesting range of patterns and colors and morphs, because they have everything from all of this combined so that you're only selecting out the best.
Yeah. And then what's eventually going to happen is you're going to get loss of access from the wild because, let's be honest, it's so archaic that like that you can go and get something from the wild, right? Like if some dog breeder was like, right, I'm off to catch a wolf. You're like, what? Do you know what I mean? So I think it's going to be a thing of the past. You're going to lose this line, and so eventually this is going to cease to exist because it can't. I can't delete it with that. It has to be this. But this won't exist because locality cannot exist and actually be locality. So it's gonna and then you're gonna end up with it being like the pure normal, and then all that is a morph. Because again, you're drifting away from the species. It's an avatar. So this doesn't actually hypothetically even exist now because we've got animals that are like eating better and more docile and like better pets. And so basically, that goes. And whether someone's doing a hybrid or not, I could remove hybrid from this entirely, and this process. This is the path.
It's the same process.
It's the same thing, right? So that disappears, and then what you end up with is basically you end up with all of this just being the same thing. It's the generic pool again.
What you end up with in another couple 100 years is just breeds.
Yeah, and then what you end up is with this. With breeds and then brackets, and then what you're going to have after all this is like new ones like that, just being like a load of new like breeds from it, and it's just like satellite breeds and like how you draw it that way, and that would have arrows from that. Yeah, but the future is that, and you cannot get away from it. You are on the road whether you like it or not, so you might as well learn how to drive.
Absolutely. It's inescapable because that is just simply what happens when you are breeding in captivity without gene flow from the wild. Humans cannot stop themselves from making selections. I mean, you could devise ways to do it. I've even known a few breeders who were so concerned about not doing visual selection that they would just like shut their eyes and randomly select the keepers. But they weren't keeping the best animals every time, that it really didn't pay to do it that way. Conservation sometimes will do things that way, but I can also tell you from the people I have worked with and known who've worked in zoos and things, um, they don't randomly select either. There is a tendency to select toward the best looking animals because you want the best display animals. Now, in a really rare animal, they won't call out a lesser animal, but I know of instances where an animal is plentiful, they call out the lesser looking animals, you know? So no one is actually doing it that I know of. That's not to say no one is, but I don't know of any. And even some of the areas where you would think it's happening, it's actually not. So yeah, this is domestication. And that's just what this is. When you take things into captivity and you take them out of the wild, they become domestic, full stop. And that's just what it is. And so it behooves people to make the best choices with their domestic stock and chuck all this ridiculous ideology down the pan and forget about it and start just making wise choices in breeding and selection. That's what's going to improve things. That's what's going to make everything better. That's what's going to make herps more popular. The easier they get to keep, the more popular they're going to become. And that's something I think everyone should be selecting toward. Uh, I mean, even difficult things, even like the tree pythons and tree boas. I hope they're selecting toward the best feeders and what'll start on mice and best temperaments because those things have a nasty bite. And just selecting. And of course, if I were going to do pythons and I were going to do hybrids and pythons, everything for me would go through ball pythons. That's a way to get rid of the deadly monsters, the giants. It's a way to notch them down some, make them a more amenable size for captivity, better temperament, easier keeping, all the things. And then the second would be Burmese, and I would select smaller lines of Burmese. I had a Burmese python because, some Burmese come from quite far up in the Himalayas. There are populations of Burmese in the Himalayas. And some Burmese in like southern China, in the colder regions of southern China, actually go into caves and hibernate in the winter. I mean, they don't go into full hibernation, but they go into the caves and utilize the caves and can take considerably colder weather. And I had a Burmese python that for years never got sick in winter temperatures down to like 50 degrees.
Well, my
So,
royal does that. Everyone says that if it drops below, like
mhm.
I don't know what 20 is in Fahrenheit. It's like 68 or 70.
68. I think it's
Yeah,
68, 70. It's in that
yeah.
range. Yeah.
But like mine has gone down to like 11 degrees Celsius, which is like what, just over 50 or
Hmm.
something.
Exactly.
Like many times at night.
Yeah. Yeah. And that's something else to be selecting for because the more cold hardy we can get them, the easier they're going to be able to be kept in temperate environments and not have respiratory infections all winter. So that's resilience. Those are things that can be selected for cold hardiness. Now, that may not be great with the pythons because, currently they've taken over South Florida, the very southern tip of Florida. The Burmese have, although there's retics and African rocks and all kinds of things down there as well. Um, and they are gradually moving north. And I believe that what's happening is as we have real extreme cold, it kills most of them off. But the few that survive that are gradually becoming hardier and hardier and are moving north. I think over time, the Burmese python will become endemic to North America and will move considerably further north. I mean, I don't think they'll go into the far frozen north,
And
but I think
it won't be a
certainly.
Burmese at that point.
Well, probably not, because they're hybridizing with retics and with rock pythons in the wild down there already. So I'm afraid they're going to become a super python. It's what I'm afraid they're going to become. What I'm hoping is that someone has accidentally released some balls that'll start hybridizing with them. But from a keeping standpoint, there are all of these traits that could be, if you find an individual that has more cold tolerance, that's just a plus you know breed from that animal, breed that trait in. If you have, whatever you need for your environment, if you find the animal that has that and it's sound on every other level, go with that. Intensify that in your breeding program. So those are all things that can be intensified. But yeah, if I was going to do pythons, I would take everything through ball. To me, balls are the corn snakes of the python world. If I were going to do boas, I would take everything through probably like red tails, because my experience is that they're kind of the calmest and the most laid back generally. They're not all, certainly. Or I might use something like a Brazilian rainbow. They're real cool. Another group of snakes that I would love to see hybridized like crazy are the rosy boas and the rubber boa. I believe those are close enough they could be hybridized, and I think they could produce through hybridization an amazing range of small, cold, hardy pet boas. Because the rubber boa goes quite far up into North America, almost into Canada in some areas. And so that I think would be a thing for people to look into. So there's all of these things out there, but at every turn I would look at what's the easiest keeper, easiest feeder, most placid, best personality, has a lot of morphs, because generally the ones that meet all those other criterion also have a lot of morphs. And then I would use them as my base, you know,
Even
and
something as
like
simple as like taking a ball python to an Angolan just to get those keeled scales just because they feel nice.
Yeah, yeah, exactly. Yeah.
Yeah.
Make whatever you want in that regard. There must be all kinds of possibilities that would. And the thing of it is, another thing that happens when you start making hybrids is you can see unique gene expressions that you don't see. Because when you get a gene homozygous in a different background, just like the example I gave you with the fibromelanotic gene in the green jungle fowl making solid black skin when in the red jungle fowl background, we may begin to find that there's a gene in this python that when put in ball becomes something completely different, or there's a gene in this pine snake that when put into this king snake becomes something completely different than in either. So there's always the possibility for unique gene expression too. um, and again, you would determine if that's genetic and reproducible just through test mating, you know? So there's all of these possibilities for things that can be combined. I mean, one thing that I like the rough scales too. I think that's a neat trait. It's one of the things I like about Pituophis. They are rougher scaled. I have always thought that the scalation that occurs when the Lapropeltis and the Pituophis are crossed is really interesting, because, you've got those highly glossy scales from the king, and then you've got those rough keeled scales from the pine snakes and the gophers, and they can make these like glossy keeled scales.
I'm thinking
Super
Imperial
cool.
to Petrophis then. That's what I'm thinking.
Oh yeah, would be gorgeous, gorgeous. Yeah, and take some of the. Have you seen the extremely bright red morphs of the Pituophis? Hot. Yeah, yeah, gorgeous. Take some of those into some of the solid red Imperials. Mm. Absolutely. See, and that's the thing, is this can get very designer. The key is going to be, because everyone is going to want to, once they realize that they can really do this, everyone's going to go designer crazy, and they're going to only be focused on the phenotype. So it won't matter how sickly it is, it won't matter how weak it is, it won't matter how poorly it feeds. They'll be trying to make these phenotypes and sell them. So what I'm begging people before this even starts is start this with sound animals and keep the animals sound. All of these things are possible. Hurt people are going to do amazing things over the next decades and centuries. But I'm begging for posterity's sake, use wise breeding methods, create these umbrella populations where you can keep the animals from getting inbred. You can breed out deleterious traits. You can breed up positive traits. Focus on temperament from the very beginning. Focus on fertility and strong neonate feeding response, and feeding on rodents. Breed these traits in from the ground level, and you'll never have to worry about them again in the future. They will be there.
Lock the foundations in, then you can worry about colour later on.
Yes, as a here's two analogies that I'll use for that. You do not put up curtains the day that you pour the foundation of your home. That's what breeders try to do when they only focus on a phenotype thing on a non-sound animal or plant. The other thing I would say is that Leonardo da Vinci did not paint the Mona Lisa on a snotty piece of tissue paper. you know? So you do not want to create your art on trash, you know? Everyone's going to focus on the art side because that's beautiful, that's eye-catching, that's what brings in the bucks. But your art needs to last, which means you need to build a strong foundation to put your art on. You know, you want to make those strong animals with good genes and good fertility and good temperament, good feeding response, all of it. Get it together. Bring it from wherever you need to bring it from. You know, maybe you want your hybrid line to be more Pituophis than anything else, and they're good, but adding a little bit of corn will make it even better. Find a huge corn snake and cross in, and then maybe never bring any more corn in. Just then select for those good corn traits, because Pituophis can be nice, but they can also be a little snotty. They're a little meaner sometimes, but they have big neonates and they have a good number of eggs. So just a little drop of corn might be just the thing to just tweak them, you know. So you want to think of these strong lineages. If where so many hybrids are done with kings and milks, call out animals that are ophiophagus. You know, if they try to eat another snake, don't use it in breeding. The really aggressive breeding males that harm the females, don't use them. Call them out. You know, put in a drop of corn and select more toward corn traits to where they don't latch onto the female, to where they don't harm the female. You know, select for those. Select for larger clutches. You know, keep the big neonate of the king, but select for the larger clutch of the corn. You know, select for them to start feeding on rodents. You know, so these are all things you can bring in these hybridization programs, and it's not a matter of, well, I want to make my hybrids and completely out of Lampropeltis. Well, that's fine, but you could still use just a drop of corn. You know, there's going to be a jungle corn in there somewhere. Just pick a good jungle corn. You know.
Yeah, I mean, I think that's the perfect ending point because I think
Yeah.
me and you are going to talk for like 6 hours. I think, but
Exactly.
I
Yeah.
think it's going to for people to just dabble in the subject. I think it's the perfect like 4 hour 4 hour podcast for people to sink
Right.
their
Right.
teeth into. So thank you so much for coming on, mate. It's been a really interesting episode, and my brain's I'm not going to sleep tonight. My brain's ticking.
Right. Well, you're so welcome. I love discussing this stuff. I love getting these ideas out. And anytime you want to have me back, just let me know. You know, if there's specific subjects you ever want to cover or questions, or, you know, we could even do something with a live stream and take viewer questions or, you know, whatever.
I was thinking that as well. Live stream, we could do that.
Yeah. Yeah.
We'll definitely
Well,
have
I'm
you
around.
on again. Yeah.
Yeah, just let me know with, you know, a little bit of little bit of time so that I can schedule it.
Sweet. Well, thank you so much for coming on.
Okay, great. Thank you.